departments, right? Let's say this is IT department. Okay, and let's say this is billing and support department. Right now in IT department there are multiple roles. Okay, like we have database admin, server administrator, system admin, network administrator, right? So let's say in this department there are 3 users, 3 employees, we can say. Dave, Tom, and Harry. Okay, Dave is a system admin. Tom is a network admin. And Harry is a DBA, database administrator. Okay, so these are the three employees which are, let's say, working in the IT department. Okay, now each of these have a designation. Let's say Dave is a system admin, Tom is a network guy, Harry is a database guy. Okay, now what we want is, let's say the AWS account admin, he has basically set up an AWS account and he wants to grant access to user Dave to the services which deals with system administration. Okay, like there are services, let's say EC2. EC2 is basically the compute service. Okay, we call EC2 as a compute service. Okay, later in the course we'll see this service in brief. Okay, EC2 is a compute service. Okay, it stands for Elastic Compute Cloud. So it is a compute service. So here basically job roles like system admin or server admin comes in. Okay, then we have, let's say for network admin, we have VPC. Okay, this is basically a networking service of AWS. Okay, VPC is virtual private cloud service of AWS, which basically deals with networking. So here basically the work is of network admin. Then we have RDS. RDS is a database service of AWS. Okay, RDS basically stands for relational database service. So this is for database admins. Now let's say the challenge is the account administrator has to provide Dave access to the AWS account. Okay, they have to provide Dave access to the AWS account. Now, if the account in order to log into the AWS account, the account admin uses the email address and a password. Email address and password. Okay, and these are the credentials which he has used to set up the AWS account. He used the company email and he has set an password, okay, to log into the AWS account. So these credentials which we use to set up the AWS account, like at the time when we create the AWS account, it asks us for an email address, password, and some other details like the organization details, company name, address, and other things, right? So these credentials, after we set up the AWS account, so we log in with email address and password. So these credentials are called root user credentials. These credentials are called root user credentials. Okay, these are the root user credential, and with these credentials, as we discussed, no restriction. The user who has these credentials, email address and password, is basically called the root user in the AWS account, root user or the account admin in the AWS account. And with these credentials, the user can do anything in the AWS account without any restriction. Okay, so now our challenge is we want to give user Dave. Dave is basically an employee in that company. He's a system admin. he works in the IT department, and we want to give Dave access to the AWS account so he can manage the servers in the AWS account, right? But right now, let's say if we directly give Dave access to these credentials, root user credentials, then Dave will be, okay, basically we want to give Dave access to EC2 service. Okay, but let's say if we provide access to these credentials, then Dave will be able to do anything in the AWS account because these are the root user credentials. Dave will be able to see the resources which are related to network, compute, database. Even he will be able to see the billing also. Everything he will be able to see. He will be able to create, delete, update the resources in the AWS account without any restriction, right? So for granular access, okay, so for granular access, basically what we do, we use the IAM service. Okay, instead of using the same credentials, same root user credentials, we use IAM service. And with IAM service, what we can do, we can create users and group. Okay, with users and group, we will be able to manage the account. Okay, access to the AWS account. Okay, with IAM, we can create users and group, and with users and group, we can grant users access to our AWS account. Okay, and with these users, with IAM, what we can do, we can also restrict access. Let's say Dave is a system admin, and we only want Dave to have access to EC2 service. Okay, we only want Dave to have access to EC2 service, but not to VPC or RDS. Okay, because those are some other services which doesn't deals with system administration. So we only want Dave to have access to EC2 service. That also we can achieve with IAM. Okay, that also we can achieve with IAM. Do you have any questions still here?
Yes, I do. So the group is, so when you're saying user access, that would be like, Tom, Dave, and Harry. When you say group access, that would be like the department, which is IT. Is that correct? And then the role is going to be, so this is like your EC2 access role, or like Tom would have.
Yeah, we'll come to role. Yeah, we'll talk about role as well.
And then after we, cover this part, I have questions about how, so when you're putting different companies under one umbrella account, kind of what that looks like. I forget the name for that.
Organization, AWS organization.
Organization. Okay, cool.
Yeah.
And then, I'd have some questions about how to transfer over services once they're already within an account, but we can go ahead with this.
Yeah. Okay, so we'll start with IAM, and in IAM we'll see now how to create users and group. Okay, so the IAM management is initially it is done by the account administrator, the one who has set up the AWS account. Okay, so we'll log into the AWS account as a root user. Okay, initially when we have set up the AWS account, we have to log in with the root user, and with that root user we'll create IAM users. Okay, let's say IAM account for user Dave, Tom, and Harry. Okay. Okay, so we have logged into the AWS account, and this is basically called the AWS Management Console. Okay, there are actually two ways to access the AWS account. One is by the AWS console, and one is by the AWS CLI. Okay, CLI we'll talk later in the course. So there are basically two ways to access the AWS account, or access or manage the AWS account. One is by the console, which is the GUI, and one is by the CLI. Okay, so here we at the left side top, we'll click on services, and here we'll be able to see all the services which AWS is offering. Okay, here we can see services categorized based on the category, let's say compute. So these are all the services which are dealing with the what the resources are related to CPU and RAM, right? The compute resources. Then storage. These services deals with data storage and database services, migration services, networking services. Okay, then here under security, identity and compliance, you'll find IAM. Okay, and this is basically called the IAM dashboard. Okay, and IAM is basically a global service. Okay, and the certification exam, they can ask a question like they will give you a question like choose choose one global service, and they will give you 4 options. Okay, let's say IAM, EC2, RDS, VPC. Okay, so IAM is a service which is global. Okay, there are a couple of more services which are global, and actually in the certification exam there are actually 4 services which we'll be learning which are global services. Okay, so IAM is one of them. Okay, IAM is a global service, which means it doesn't require any region selection. Okay, plus when we are creating a resource in IAM, so it is that specific resource is not created in a specific region, it is created globally. Okay, now here basically we can see the stats of our AWS account, like how many users we have, how many groups we have, how many roles we have. Okay, how many policies we have. So here we'll go to users. Okay, if you'll be setting up the AWS account for the very first time, you'll find no users here. So I'll just delete this users. Okay, initially, like when we'll be setting up the AWS account, there will be no users. Now, the problem we were facing was like we wanted to grant access to a user in the company in the IT department to a service EC2, right? So first what we'll do is we'll create an IAM user. We'll create an IAM user for user Dave. So here we'll give the username Dave, and then the access type. As we discussed, there are 2 ways to access the AWS account. So here you can see we can see 2 access types. One is programmatic access, another is AWS Management Console access. So AWS Management Console access is this one, the one which we are using right now. It is the AWS Management Console access. Then programmatic access. Programmatic access is basically API based access. It's basically the AWS CLI. AWS CLI is an example of programmatic access. There are a couple of other ways also to access the AWS account, but I mean, most oftenly we use AWS CLI. So right now we are creating a user Dave, and Dave we want to give access to the console. So here we'll be choosing AWS Management Console. Okay, we can choose both types of access also. With that, basically the user will be having access to the Management Console also and to the CLI also. Both also we can give. So for now, we'll only give Management Console access. Then if we are giving Management Console access, then it will ask us to set a password for the user to log into the AWS account. And based on the IAM best practices, AWS IAM best practices, AWS recommends that we set auto-generated password. Okay, auto-generated password is a very strong password based on the password policy set in our AWS account. Okay, password policy will come to that also later in IAM. We'll talk about password policy. that is with which basically we set password complexity. Okay, and when we choose auto generated password, the password will be generated with that IAM password policy. Okay, or we can also set our own password, a custom password. We have to set our own custom password here. But AWS recommends to use a auto-generated password, which is a mixture of which is basically based on the IAM password policy we have in the account. Then we have another setting which says require password reset. Okay, and this is also recommended by AWS that we enable this setting, which means when the user Dave will be logging into the AWS account for the very first time, the user will be asked to change his own password. Then next, permission. Okay, now here in the permission setting section, we have couple of ways to give permission. Okay, now in AWS, if you want to give access to a user, okay, you have to grant some privileges to a user. So in AWS, basically we use IAM policies. Okay, we use IAM policy. Okay, and what is an IAM policy? IAM policy is basically a JSON document which has a set of rules, okay, which describes what the user will be able to do in the AWS account. Okay, so right now we'll keep this as blank. We'll come to this later in the set permission. We'll come to this, get back to this later. So right now we'll not attach any permission, or we'll not attach any, we'll not add the user to any group. Okay, then tagging we'll be talking later when we are familiar with 2-3 services of AWS. At that time we'll talk about tagging. Okay, now here it's basically saying that we are creating a user Dave, and we are giving management console access with the password, and the password is auto generated. Require password reset is set to yes. Permission boundaries is not set. Okay, permission boundary is also a concept in IAM. Then create user. Okay, so the user has been created, and this is the username Dave, and this is the password, auto-generated password, which AWS has generated. Okay, and this password fits with the IAM password policy set in our AWS account. Okay, by default, every account has a password policy. Okay, default password policy. So this password which is generated is basically generated by the IAM password policy of the AWS account. Do you have any questions still here?
Yes. So the policy, which is the JSON document with the set of rules, is a policy able? Are you able to attach it to, so you an individual user, or to a role, or to a group, or does it matter?
Yeah, IAM policy we can attach to a user also, group also, and role also.
Okay, so
Any
that
IAM.
that's okay. And then
we'll come to that once we are. We'll come to that also. Yeah.
Okay, and then I saw the permissions boundary. What is that?
Permission boundary is basically if we have multiple users, and we want to restrict access. We want to restrict access to some resources. Let's say we have 2 users with the same permission. Okay, but one user we have to restrict access to some services which a user has access to. Okay, so in that case, basically we use permission boundary. Okay, we'll talk about that as well. We'll talk about that. Okay, so the user Dave has been created, and now here I'll open one incognito mode, and in this incognito mode, we'll log in with user Dave.
Did you have to click on the send welcome email, or does it just send it?
Yeah, we can also send an email that will basically open the Outlook or Gmail, whatever we are using, and with that, basically the credentials will be mailed to the user.
Yeah.
Okay, or we can also download the CSV file, and we can give to the actually the IAM administrator who is managing the accounts in IAM, and he can also forward it to the concerned person. Yeah.
Okay.
Okay. Now to log in with user Dave. So we have created the user Dave. I'll just copy this password. Okay, so in user we can see the user has been created. And now here at this tab, let's say I'm user Dave, and Dave user is trying to log into the AWS account. So to log into the AWS account via an IAM user, so what we need is we need the account name. We need the account name or the account ID. Okay, so at the time at the time of creation of the AWS account, so it basically asks us an account name, right? Let's say if we click here to create a new account, so it will basically ask us an AWS account name. Okay, and this is the name. This is our account name. Okay, every AWS account has an unique account name. Okay, every AWS account has a unique account name and 12-digit account ID. Okay, every AWS account has a 12-digit account name and account ID, and account name is actually optional. Even if you will not specify here, then also it is fine. This is actually an optional field. Okay, here it says required, but let's say if you after creating the account also we can actually we can remove it. Okay, right now in this account I have an account alias, but let's say we can remove it also. Once we remove it, it will only work with the account ID. Let's say delete alias. Yeah, so now it will only work with account ID. So it's basically optional. Okay, you can also work with the account ID. Okay, as an account name, basically we give the company name. Okay, it's basically creating a mapping. Okay, like in our phone number, in our phone, basically what we do, we save the number by a name. Okay, and when we are calling that name, we are not actually calling that name, we are calling that number which is behind that name. The same way here also we are doing that mapping. We are mapping the 12-digit account ID with a name. Let's say the account name, the company name.
So you can change this whenever, and it still will map back to your original 12-digit.
Exactly,
Yeah.
exactly. But it should not be in use. Let's say I have kept this name. So let's say if someone tries to create the AWS account and with this name, my company 001, he'll not be able to create the account.
Okay.
Okay, because this name is now in use.
So, but if you delete it,
yeah, if we delete it, then
become
some other,
free.
yeah, exactly. Okay, so first it is asking us for the account ID or account alias. So let's say if in our AWS account we don't have the account alias, then here we have to provide the 12-digit ID. Okay, or we can provide the account alias. Let's say we have set up the account alias as my company 001. Then username is Dave, and the password. Okay, also we can give this URL to the user. In the mail, we can also send this URL to the user. This is also called the IAM sign in URL. Okay, IAM user sign in URL. With this URL, the user will be directly redirected to, let's say if I open this URL, let's say in some, yeah, let's say if I open this URL directly, so automatically it will fill the account ID, account ID parameter, this one. It will be automatically filled if we go with this URL. Okay, if the IAM user has this URL. Okay, actually, after copying that link, I actually misplaced the password. So what we'll do is, yeah, like now when the user Dave is logged in, so Dave is basically asked to reset his password based on the setting we have set at the time of creation of the user. right? So now here it is basically asking the old password. Okay, but by mistake when we were copying that link, so my password got changed. I mean that field got changed in the clipboard. So I'll just perform a reset of the password of the user. So this is the user Dave, and then we can go to security credentials, and here you will find console password, and here you will click on manage, and here we can set a auto generated or custom password, and the new password has been generated. Copy, and here we'll paste the old password, then the new password, and confirm change password. Oops. Okay, now user Dave has logged into the AWS account, right? So right now we are logged in with the IAM user, and to identify that, here we can see IAM user and the username, and this is the account ID. Now Dave is a system admin, so Dave should have access to, let's say, EC2 service or all the services which deals with system administration, right? But now when Dave goes to EC2 service, he gets an API error. Okay, and let's say if we go click on, so here basically let's say the user Dave clicks on security groups, he gets, you are not authorized to perform this operation. Okay, which is basically saying access denied, or permission denied, right? Because right now Dave is not authorized to access any of the resources in the AWS account, right? So there is one question asked in the certification exam, that when we create a user, IAM user without any IAM policy, without attaching any IAM policy to the user, what access the user has in the AWS account? So there will be four options saying the user will not be able to log into the AWS account, or the user will have access to all the services, the user will have no access, and none of the above. So the answer will be the user will be able to log into the AWS account plus but the user will not have access to any of the services in the AWS account. Okay, like we didn't attach any policy to the user, but still the user is able to log into the AWS account, but the user is not able to access any of the services in the AWS account, right? Do you have any questions still here?
Nope.
Okay, now we'll be talking about IAM policies. So with IAM policy, basically what we do, we grant, in that IAM policy, in IAM policy, basically we have the rules, and those rules basically defines what the user will be having access to in the AWS account. Okay, there is one question which is asked in the certification exam, which is commonly asked in the certification exam. In which language is the IAM policy written in? So IAM policy is a JSON document. So IAM policy is basically written in the JSON language. Okay, it is written in JSON. It has the set of rules which describes what access an IAM entity will have. Okay, it has set of rules which describe what access an IAM entity will have. What is an IAM entity? Do you know what is IAM entity?
A user or a group
Okay,
or a role. Oh,
exactly.
okay.
Whenever we are talking about IAM entity, we are talking about user, group, and role. So, as we like as we talked about IAM policy, so IAM policy is a set of rules which describe what access an IAM entity will have. So it could be a user also, a group also, and a role also.
Hey, is it Gaurav or Gaurav? How would
Gaurav,
I say your name?
Gaurav.
Gaurav.
Yes.
I'm just gonna switch my Wi-Fi real quick. It should just take less than a minute. So the one that I'm on is saying it's unstable.
Okay,
One
sure, no problem.
second. Okay, can you hear me? Gaurav, can you hear me? Gaurav, can you hear me? Let's see. Gaurav, can you hear me? Hmm. Gaurav, can you hear me?
Yeah, I can hear you.
Okay, I'm back. You can go ahead.
Yeah.
Thank you.
Okay, so IAM entity is basically a user, group, and role. Okay. Now IAM policies are basically of three types. Okay, IAM policy is basically of three types. Do you know what the different types of policies, IAM policies?
I do not.
So we have three types of policy. One is AWS managed policy, customer managed policy, and inline policy. We have these three types of policies: AWS managed policy, customer managed policies, and inline policy. First, let us talk about AWS managed policy. AWS managed policies are created and managed by AWS. Okay, so these are the policies which are created and managed by AWS. And by default in the AWS account, when you will be creating a fresh AWS account, you'll only find AWS managed policies in the AWS account. Okay, so AWS managed policy is a type of IAM policy which are created and managed by AWS. Okay, we cannot update, sorry, we cannot create, update, or delete a AWS managed policy. Okay, we cannot create the IAM policy, we cannot update the policy, or we cannot delete an AWS managed policy. So if we go to the console, so here at the left side, you'll find policies. Yeah, so these are all the policies. Okay, and these are all AWS managed policies. How we can identify that it is a AWS managed policy? We can see here in the type, it says AWS managed, AWS managed, AWS managed. Another thing which we can see is this logo. This logo also defines that it is an AWS managed policies. For other types of policies, like customer managed policy or inline policy, we will not find this logo. Okay, we will not find this logo. Okay, and the AWS managed policies are also of, there is one category of the AWS managed policy, which is job function. Okay, job function is basically a type of AWS managed policy. Okay, it is a type of AWS managed policy. Okay, and in this policies, basically you'll find policies based on job roles. Based on job roles. Okay, so it is basically a type of AWS managed policy, and here you will find policies based on job roles. Let's say we have a system admin. Let's say a system admin has joined the company, and we want to give that system admin access to all the services which deals with system administration. Okay, now AWS is expanding daily. Okay, daily AWS is updating their services, bringing new services. Okay, every new week or every 15-20 days, basically we hear that AWS has added a new service or updated existing service, right? So they are very rapidly expanding, right? And it's very difficult for anyone to basically be updated with that frequency to let's say create IAM policies or yeah, to create an IAM policy which have access to all those services. Okay, so in that case, that part is basically done by AWS with job function policies. Okay, in job function policies, you will find policies like system admin, database admin, network admin, security audit. Give me a minute, I'm getting one call. Just give me 5 minutes. Okay, so in job functions, we were talking about job functions. So in job functions, job function is basically a type of AWS managed policy, and there we basically have policies of job roles like system admin, database admin, network admin, security auditor. There is one more role called billing. Okay, if we go to the console, so here basically we can filter the policies. Okay, filter the policy based on types. So let's say AWS manage. So here you can find two categories: AWS manage and AWS manage job functions. Okay, so job function is a type of AWS manage policy. Now let's say if we click on AWS manage job function, so here we can find all the job function policies. Okay, but these are type of AWS managed policies. Okay, and if we see these job function policies, so they are like administrative access, billing, database administrator, data scientist. These, if we see all these policies, they are basically based on job roles. Like company has for IAM administrator, database admin, data scientist. This is also very hot job role in the market today. Network admin, power user, security auditor, support user, system admin, and this is view only access, which is more like read only access to the AWS account. So these are a couple of job roles. Okay, So instead of creating our own policy, like creating, let's say a system admin is joining our company, and instead of writing our own policy to, to grant access to our AWS account to all the services which are of system admin. So that will be a very time consuming process. Plus you have to keep on updating the policy. Why? Because AWS keeps on updating their services, and they keep on adding new services. So every time you have to keep those policies updated, right? But now this with job functions, AWS managed job function, all the policies, these kinds of policies are managed by AWS. So let's say if they have added a new service, so they will update the policies also, because it is a type of AWS managed policy where the policy is managed by the cloud provider, right? Do you have any questions still here?
So if you look into these policies, are you able to look at the JSON document associated?
Yeah, we can see the JSON document. If we, let's say if we click on
Okay.
this policy, we can see the JSON code.
Okay, so like in theory, if you wanted to grant access to everything that an admin would normally have except for this one thing, you could look at the document and be like, okay, I'm just going to copy this, I'm going to create a new policy, and I'm just going to remove this one service that I don't want them to have access to.
Exactly.
Okay.
But this is an AWS managed policy, and here you can see it says read only.
Yes, okay. Yep.
This is an AWS managed policy, which AWS will update this policy automatically when new features are released. Okay, so we cannot delete this policy, update this policy, or we cannot create an AWS managed policy, because these policies are managed by the cloud provider, by AWS. And so here basically we can see what policies, what is the permission basically it is granting. With JSON, we can see the JSON structure of the policy. And in policy summary, we can see what services this policy is basically granting access to. Let's say these are all the service name, full access to all resources, no condition. Then policy usage, here we can see what to which IAM entities this policy is being basically attached to. Then policy version, each of these policies basically have a version. Okay, when we will be creating our own policy, that time we'll get more clarity about policy version, policy usage, and this part. Okay, other than these job function policies, if we just look the AWS managed policies, so these policies are basically based on the service name. Okay, service name, let's say service name and full access, service name read only access, service name full access, service name read only access. Okay, so in AWS managed policies, we'll be seeing most of the policies as AWS service name full access, AWS service name read only access. So most of the policies you'll find, which are just AWS managed policy, you'll find these kind of policies. Okay, for example, it will look something like this: AWS EC2 full access, AWS EC2 read only access. Okay, these kind of policy will be seen for all the services. AWS managed policy, you'll find these policies: AWS service name full access, AWS service name read only access. Okay, which is basically granting either full access or either full access to that service, like read, write, update, delete access, and with read only view access. Okay, the user will be able to just see the resources. Okay, there is no granular permission. Okay, granular permission, it means if you want to grant access to a specific resource, that you cannot do with AWS managed policies, right? Okay, now to solve that problem, like to solve the problem of granularity. Okay, let's say you want to grant access to a specific resource. Okay, there are two things: one is service and then resource. Inside a AWS service, we have resource. Okay, So these policies are basically granting access to whole service. They are granting access to the whole service. Which policies? AWS managed policies. They are not granting access to a specific resource. They are granting access to whole service. If we grant access to whole service, automatically access to all resources are also granted. Okay. So for granularity, let's say we want a user to have access to a specific resource in the account. So to achieve that, basically we use customer managed policies. And in customer managed policies, basically we need to write an IAM policy. Okay. So customer managed policies are created and managed by us. We can create it, update it, delete it. Okay, we can create it, update it, and delete it. Okay, but here in customer managed policy, we have to write the IAM policy. Okay, with customer managed policy, we can grant access to a specific resource. Okay, which we can also say we can give access, we can basically achieve granularity. Okay, with customer managed policies. Okay, now let us talk about how we can create a customer managed policy. Do you know how to create a policy?
Well, I've never created one, but I would assume that you um, go in the
Yeah,
console and you can add it there, but you'd have to actually write the JSON document.
Mhm. Okay, first let us talk about the IAM policy structure. Okay, if we talk about the policy structure, so as we already discussed that it is written in JSON. So there are like couple of I would say pairs. Okay, the first one is version, the policy version. The second one is statement. Okay, second one is statement. Okay, statement is basically you can say a description. Okay, version you can say policy version. Okay, if you know this, like the structure of a policy, it will be very easy to understand any IAM policy, plus it will be very easy to write our own policy. Okay, there are a lot of ways to create the policy, even we don't have to write the code. So here first we have allow. Okay, allow, then action. Okay, in allow basically we have two things, deny or grant. Okay, if we see any of these policies, you see any of these policies, we will find few things common. Okay, let's say this one. We will find few things very common, like version and statement. Okay, these will be common in all the policies. Okay, and then we will find effect, action, resource. So we have effect. Actually, effect will come here. Effect, action, resource, and one more thing is condition. Okay, so in effect, basically we give access. What will be the access, whether to allow or deny? Okay, here we'll be having allow or deny. If you see a policy, so here we have effect. An effect is basically telling allow or deny. Here is it's showing allow or deny. So first statement is allow. Then allow access to what resource? That we are defining in action. So in action, basically we give the service name. Let's say EC2 service. And in EC2 service, access to what action? Okay, action like launch instance. Or create instance, stop instance, start instance. What action we want to give? Or let's say you want to give full access to EC2 service. So it will look something like this, asterisk. Asterisk means, asterisk will come across asterisk a lot of times. Asterisk means all. Okay, so here asterisk means all actions. Okay, now let's say if here we just give asterisk in action, if we just give asterisk means all access to all the services in AWS. Let's say if we give here asterisk, so this asterisk will mean all access to all services and all actions in the AWS account. Then resource. And here basically we have to give the resource name. In AWS we call resource name as ARN. Do you know what is ARN?
It's your resource number.
Yeah, ARN stands for Amazon resource name.
Oh, gotcha. Name, not number.
Okay, all the resources which we create in AWS has a ARN. Okay, these policies also have a ARN. Let's say if we click on this policy, so here you can see policy ARN. So all the resources in the AWS account has a ARN. Okay, let's say if we copy this ARN, let's take an example of a user ARN. So let's say this one. All the resources has a ARN. So this is the ARN for an IAM user. So in ARN, basically we have this part. Okay, this part is prefix, is common in all the ARNs. Okay, then we have the second part, which is this. Then the third part this, fourth part is this, fifth part is this, and sixth part is this. Okay, so the first is just the prefix. Okay, first is just the prefix. Prefix, it means it will be in all the ARNs. Then IAM. What is IAM? IAM will be the service name. It can be any service name. Right now, this resource, I mean, we copied it from IAM. So right now, that's why the service name is IAM. Then here, actually, there is a gap. There is a gap because IAM is a global service. That's why here is a gap. If there is a gap, it means there is no region specification. Okay, so here basically we give region name. IAM is a global service, that's why it is blank. Then account ID. Then resource name. then sorry, not resource name, resource type. This will be resource type, and Dave is that is the resource name, resource type, and then the resource name. So first is the prefix, then the service name, then the region name, account ID, resource type, and resource name. So in this section of resource in the IAM policy, basically we give the resource ARN. Okay, like here, let's say you have given, we have to grant access to EC2 service. Let's say here we have written, we want to grant access to EC2 service, and we want to grant all actions. Okay, all action means colon asterisk. Then here you can restrict that access to a specific resource by a resource ARN. Here you can give the resource ARN. Let's say you only want to grant access to a EC2 instance. Do you know what is a EC2 instance?
Yes.
Yeah, so let's say you want to grant access to an EC2 instance. So that ARN of the EC2 instance you can give here. Or you can also type in here asterisk. Instead of ARN, you can also give asterisk. Asterisk means access to all the resources in this service. Access to all the resources in this service. Or you can give the resource ARN. So the user will be having access to only this specific resource. What access? This access. This access to this resource. The resource ARN which you will specify here. Now the last thing is condition. Condition you will not find in if we talk about the basic policy structures, so you'll find commonly you'll find these three things: effect, action, and resource. If we see any AWS managed policy, so mostly we'll find those three things. Let's say administrator access policy. So effect, action, and resource. Okay, version is just a date that is actually from AWS end that we have to give here, and that is also optional. Okay, effect, action, and resource. Then we have condition. Then we have condition. In condition, basically we can give source IP. If source IP is equals to, let's say, this IP. Let's say you want that the employee, the company's employee, should have access to the AWS account and should have access to these services and these resources which are mentioned here only if the user is logging in from the company network. So that we can add it as a condition. Okay, that you can give your company's public IP. So if the user is logging in with that IP address, which will be the company network IP, then only the user will be able to log into the user will be able to log into the AWS account, but he will gain these accesses. Okay, also you can add a condition that if region is, let's say, Virginia. Okay, so here you can add a resource, let's say condition Virginia. So the user will be having access to all the resources in Virginia. Okay, that kind of restrictions basically we can add using conditions. Okay, condition basically what it is checking when a certain rule is matching, when a certain condition is matching with, if it matches, then allow access. If it doesn't matches, then deny the access. That's what condition is doing. Okay, but mostly we'll see effect, action, and resource. Okay, if you see this policy, so it's very easy to write the policy. Okay, only three things we have to keep in mind: effect, action, and allow. In effect, basically we write allow or deny. Then action, basically we give the service name. Right now this is an administrative access policy, so it says asterisk asterisk, access to all the services and all the resources. But if you want to restrict access, then the service name and what action you want to provide. Okay, action list, I'll show you how we can get what are the actions available in a specific service. Then resource ARN. Resource ARN also you can get from the AWS account itself. Then condition. Condition is also you can get from the AWS account itself. There is basically a pop-up where we have to set the conditions. Okay, any questions still here about the policy structure or
Um,
ARN?
Yes, so it seems that the version and the condition are optional, but you must have the effect, action, and resource as part of the
Yes,
statement. Is that correct?
exactly.
Okay. And if you were to add more than one specific resource that you're granting access to, would that then become an array or an object, or how do you know how that's structured?
Sorry.
If you wanted someone to have access to more than one specific resource,
Yeah,
um,
we can have like we can add comma separated. It's basically comma separated. We
okay,
can give multiple ARN names here.
cool.
Like let's say ARN1 comma ARN2 ARN3, that we can do.
Okay.
Multiple resources we can grant access. Yeah. Okay. Have you ever created an IAM policy?
No.
Okay, so there are a couple of ways to create the IAM policy. Okay, one we can do by the AWS console, which is the very easiest way to create the IAM policy. Basically, they provide a visual editor, so we even don't have to know JSON. Okay, so if we go here, policies, create policies. So in console, basically they are giving us two ways. One is using the visual editor. Okay, even if we don't know JSON, then also we can create using visual editor. Now let's say if you already have a policy, then you can go to JSON and copy paste your policy here. Or we can also use the visual editor. Visual editor is very easy to use. You just need to choose the service name. Let's say you want to grant access to EC2 service. Then what action you want to give? Like here in the policy, we have type the action, like what action you want to give. So let's say for all action, if we click on this, it means EC2 colon asterisk. So your policy will have that statement, EC2 hyphen asterisk. When the policy is, I mean the visual editor, if we complete all the settings, then we will be able to see what policy it has generated. The policy will also be generated here. Okay, EC2 asterisk, which means access to all the services, all the actions under EC2 service. But let's say if you want to grant granular access to a specific resource, then here we have access levels. Like what kind of access we need to provide. Describe, like let's say here we'll find, let's say describe volume. Like when we launch an instance, a volume is attached to the instance. Let's say describe instances, describe image, describe instance status, describe instance types, describe key pairs. Depending on our use case, we can give access. Now let's say describe instance type. Now let's say we don't know what this action will be doing. So here we'll find and pop up like a question mark button. If you click on that, so it will give you a description what that particular action will do. So let's say this one, describe instance type, grants permission to describe the detail of instance type that are offered in a location. Okay, are you familiar with instance types?
Um,
That is like T2.micro, T2.medium, those are instance types.
sure. Okay.
Okay, then what resource we want to grant access to. Now, depending on our selection, depending on the access level we have given, so there is no, I mean, there is no need of adding the resource, the ARN section. Okay, now let's say if we give access to write access means create access. Okay, create or modify access. Okay, let's say you want to give access to reboot the instance. Okay, now here you can find a resource section. Reboot instance, like let's say you have 5 instances. So 5 instances means you have 5 resources. Now, out of those 5 resources, what resources you want to grant access to? So that basically we can have here. Let's say if you give specific, okay, there are two things, specific and all resources. All resources means asterisk, and specific means you have to provide the resource ARN. Okay, here you have to provide the ARN of that EC2 instance. Okay, let's say we set it to all resources. And if we go to JSON now, so here you can see the policy, it is generated. Okay, it is generating the policy. And if you see in the policy, this SID is not required, it's optional. So here you can see effect, action, and resource, the three things: effect, action, and resource. And let's say if you want to give multiple actions, so they are comma separated. Same way you can, if you want to add multiple ARNs, so you can add it with comma separated. Then let's say if you want to add a condition, okay, condition like source IP. If the IP address of the user is matching with the company network, okay, for example, if it matches the company network, then only grant access. Or if the user is connected with the VPN only, then only grant access. So that we can add in here. So if the user is not logging in from the company network, he will not be getting access to those specific resources. Then one setting is MFA required. If the user doesn't have MFA enabled, the user will not be granted access to the above resources.
Is that the MFA on just their initial login, or does that require some sort of login for access to that service?
It's at the login of the user. If the user is not logged in with MFA, these access will not be granted to the user.
Okay.
Now if we go to JSON, so it has added the condition section also. So we don't have to write the JSON policy. It is automatically, if we use the visual editor, it will be automatically generated. Okay, one way of creating the policy is via visual editor. Another way is AWS provides a policy generator, an official policy generator. Okay, so let's say IAM policy. Okay, like in AWS, for a couple of services, we have a couple of services, they have their own policies. Like IAM is basically for user management, and whereas for some of the services we have resource policies also, like SQS, SNS, S3, S3 has bucket policy, SNS has topic policies, right? So let's say we want to create an IAM policy. Then here also you can see the same things: effect, service name, what action you want to grant, and the ARN. So let's say allow access. Then allow access to which service? Let's say S3 service. Then what action we want to provide? Let's say create bucket access. Then to what resources? Let's say a asterisk. Then add statement. What this will do? Then here you will find an option of generate policy. So the policy has been generated. So just what you have to do is you have to just copy it and go to here JSON and paste it. That's it. And if you'll go to visual editor, the policy will also be changed. Okay. Do you have any questions about creating the IAM policy?
Nope.
Then next, add tags. Tags we'll talk later. Then the policy name. Let's say my IAM policy. Okay, let's say my IAM policy for S3. Okay, and it's always good that we provide a description. Description is optional though. So here we can write this policy grants access to create S3 bucket, so that the others who are working in the account can know like for what purpose this policy has been created. Then create policy. And here in filter policy, if you click on customer managed policies, here you can find all the customer managed policies. By default, you will not get in a fresh AWS account, you will not see any customer managed policies. So here you can see my IAM policy for EC2. So sorry, for S3, the one which we just created. So it says this policy grants access to create S3 bucket. And if we click on this policy, here you can see this is the code of that policy, JSON code. And if you go to policy summary, it will show what access will be given to what resources. Sorry, what services. Now you can edit this policy. You can edit this policy. Here you can find this option, edit policy, delete policy. Whereas in AWS managed policy, you will not find an option of update or edit policy or delete policy. Okay, there you will not find any option of edit policy or delete policy. So if you want to edit this policy, we can just click here, and by the visual editor we can edit, or by JSON also we can edit the policy. So a customer managed policy, we can edit it, we can delete it. And if you go to policy version, so IAM policies are basically immutable. Okay, IAM policies are immutable, which means you can edit it. You can actually not edit a policy. When you are editing a policy, you are actually creating a new policy, a new version of the policy. Okay, like here right now, this is the first policy which we have created. So here we can see version 1. Now let's say when I'm editing the policy, okay, so the existing policy will not be modified. A new version of the policy will be created. Okay, because IAM policies are immutable. Now let's say here in action, I'll add one statement, or let's say access to a specific resource. Let's say I want to deny access. So let's say deny. And review policy, save changes. So I made a change. I revoked the access. Okay, basically we gave deny access. Now, if you go here to policy version, so a new version has been created of that policy. Okay, this says deny, and you can see the version 1 also. The old policy also you can see. It says allow. Okay, so IAM policies are immutable. We cannot modify, we cannot edit the IAM policy. Okay, we can edit, but at the time when we are editing it, basically we are creating a new policy, a new version of that policy. Okay, and we can create up to 5 versions. Okay, if we'll be creating more than 5 versions, so it will ask either to delete the policy, or it will give us an error that we cannot create more than 5 versions. Okay, so this can be asked in the certification exams. Like there could be a question saying, like, are IAM policies mutable? Like, which means we can edit it. There could be true or false. Okay. Another thing they can ask is like, what are the number of versions we can say for an IAM policy? Okay. Another thing which can be asked in the certification exam is, are you making some notes?
Yes.
Okay, IAM policies are immutable. We can create up to 5 versions of a policy. Okay. Third thing is policy size. Okay, so there is a limit of the size of the policy. Yeah, so these are the quotas. Uh, that is actually in one of the okay, this is something which AWS keeps on changing. That's why I'm referring this. Yeah, so here we can see. One second. Yeah, so these are the quotas, like file size. Let's say if we are creating an IAM policy for a user, so it could be of 2048 characters. For a role, it could be of 10,000 to 40 characters. A group policy could be of 5,120 characters. Okay, this is basically limit for inline policies. For managed policies, the size could be of 6,144 characters. Okay, this actually we can see in the console also. At the time of creating the policy, let's say if we edit this policy, so here you can see character count. The character count cannot be more than 6,144. Okay, for customer managed policy, the character count cannot be more than 6,144. For an inline policy, okay, depending on the IAM entity, it basically differs. Let's say if you are creating an inline policy for a group, for a user, group, and role. So there are some limits. For a user, it is 2000, 2048. For a role, it is 10,000. For a group, it is 5,120. Okay, this is for inline policies. Do you know what are inline policies?
I thought that inline policies were policies that were only assigned to a specific user.
Exactly. Exactly. It can only be assigned to a single entity, single IAM user, a group, or a role.
Gotcha.
Yeah. Yeah, actually, these limits we can say like 6 KB. If we talk in terms of kilobytes, so 6 KB, this basically means 2 KB, 10 KB, 5 KB. Okay. Okay, do you have any questions still here about customer managed policies?
No.
Okay, now we'll be talking about inline policies. So in inline policies, they are same as customer managed policies. Okay, inline policies has all the characters which a customer managed policy has. Like inline policy, we can create it, we can update it, we can delete it. Same as customer managed policies. We can create the policy, we can update the policy, we can delete the policy. The only difference between customer managed policy and inline policy is it can only be attached to a single IAM entity. It can only be attached to a single IAM entity, which means, let's say if you have created an inline policy and if you have attached to a user, to a IAM user, let's say Tom. Now the same policy you cannot attach to some other user or to a group or to a role. It can only be attached to a single IAM entity. Whereas if you have created a customer managed policy, so you can attach that policy to multiple IAM entities. You can attach to multiple users, multiple groups, multiple roles. Okay. There is one more difference, which is when the IAM entity is deleted. When the IAM entity is deleted, the policy also gets deleted. Okay. When the IAM entity is deleted, the policy also gets deleted. But here in customer managed policies, if the IAM entity is deleted, let's say you have created a customer managed policies and you have attached to an IAM user. And let's say if you delete that IAM user, the policy will not get deleted. Whereas if you have created an inline policy and if you have attached to that to a user or to any IAM entity, so if that IAM entity is deleted, so the inline policy will also get deleted. Okay, so these are some of the differences between customer managed policy, similarities and differences between a customer managed and inline policies. Do you have any question?
No.
Okay, if we go to the console, so to create an inline policy, you don't have to go to policies and you have to create the policy first. Okay, from here, basically we create the customer managed policies. To create an inline policy, you have to go to that IAM entity for which you have to create the inline policy for. So let's say you want to create an inline policy for Dave user. So you'll click on user Dave, then you'll go to permissions, and here you will find an option of add inline policy. So to create the inline policy, first you have to make sure that that specific IAM entity already exists. So right now we have that IAM entity, which is an IAM user Dave, and now we can click here add inline policy, and we can create the policy. Okay, so let's say you want to create an IAM policy, let's say for, okay, the creation will be the creation for the policy will be the same as we create the customer managed policy, but this will be only attached to an IAM user, only for a specific IAM user. So right now I'm creating a policy which is giving access to EC2 service, all actions, and access to all the resources, like full access to EC2 service. And then if you go to JSON, here you can see the code. Plus, if you see here the character count of the policy, it says 2048, right? But if you see, when we were creating an customer managed policy, so we saw the character count 6144, right? So for customer managed policy, the character count is 6144. Whereas if you are creating the inline policy for a user, so the character count is 2 KB, 2048. If you are creating for a group, it is 5 KB, 5120. For a role, it is 10,240. Okay. So in the certification exam, they can ask question related to this. Like if you are creating an IAM policy, if you are creating a inline policy for a user, what will be the character count of the policy, or what will be the policy size? Okay, if they are asking character count, then they are referring to this number. If they are asking for the policy size, then they are referring to this number, 2 KB, 10 KB, 5 KB. Okay, and for a customer managed, it is 6 KB. It is fixed for user, group, and role. It is fixed 6 KB. Okay, now let's say my inline policy. The creation is same. The way we created the customer managed policy, the same way we created the inline policy. Here you can see the policy has been created and it has also been attached to the user directly. And here you can see policy type inline. But this policy, if you try to see here, if we search for that inline policy, so we'll not find the inline policy here. Okay, we cannot see the inline policy here. We can only see the AWS managed policy and customer managed policy is here. For seeing the inline policy, we have to go to that specific IAM entity. So here we can see the inline policy. Now let's say when we delete this user, let's say if we delete this user Dave, the policy will also get deleted. Okay, when we delete this user, the policy will also get deleted. Whereas if you will be deleting the inline policy, it will not affect the resource. It will not affect the IAM entity. But when we are deleting the IAM entity, the inline policy will also get deleted. Okay. Okay. Do you have any questions about the IAM policies?
No.
Okay.
Actually, is there a limit to the number of inline policies that you can assign to an entity?
Yeah, there is a limit. Actually, for all the services, there are limits, which are basically called service limits and service quotas. Okay. So let's say if we want to get the information of service limits for a specific service. So we can go here, and here basically we have my service quotas. So in service quotas for each of the services, we can see like what resources we can create, the number of resources we can create. So let's say here, if we go to AWS services, in service quota, then we'll go to AWS services, and here we'll search for IAM, where you can see this is the service name, IAM. And here you can find a quota, like how many policies you can create, how many users you can create, how many groups you can create. So let's say for IAM policy. Yeah, here you can see the policy length also 6144. Policy limit also we can see. Yeah, here you can see customer managed policies per account. So you can create up to 1500 policies, and to a user or to a role you can attach up to, here you can see managed policies per user. You can attach up to 10 policies, 10 customer managed policies or 10 inline policies, or you can attach 5 customer managed or 5 inline policies. Okay, to a user. To a role you can attach up, yeah, for a role also you can attach up to 10 policies. For a group also you can attach up to 10 policies. And these policies, I mean, it means it could be an AWS managed policies, or it could be a customer managed policy, or it could be a inline policy, but it should not exceed more than 10 policy. Okay, then here we can see number of IAM users we can create an account. Okay, there are few things, few numbers which we have to remember, which can be asked in the certification exam, like how many users we can create in an AWS account. So we can create up to 5,000 users. And here you can see that limit which we discussed, which was versions per managed policy. Here you can see we can create up to 5 versions. Tags we can attach per user, 50 tags we can attach. MFA per user, 1. Okay, not all we have to remember, only few we have to remember, which are related to the user groups and roles. Then policy length we already discussed. Then policies, the number of policies we can attach to a user, 10, for a role 10, for a group 10. Okay, then IAM groups per user, like we can add up to 10 users in an IAM group. How many IAM groups we can create? We can create up to 300 IAM groups. Okay, 300 IAM groups we can create, and 5,000 IAM users we can create in an account. and 300 groups we can create. Then customer managed policies, the number of policies we can create up to 1500 policies in an AWS account. So here for each services, we can get the quotas, we can get the limits. Okay, let's say for EC2. So here we can get the limits. Okay, not all limits we have to remember. I'll tell you the number of not number. I mean the ones which I have seen commonly in the certification exam. So the question will also be as I mean we'll see most of those limits only in the certification exam. Okay, do you have any questions still here?
Nope.
Okay, I'll type here the limits also. For an IAM user, we can create 5,000 IAM group, which can be asked in the certification exam, like 300 manage policies. Let's say policies, we can create 1500. IAM user to a group, sorry, IAM group. In our IAM group, we can attach, we can add 10 users in IAM group. We cannot add more than 10 IAM users in a group. Then to an IAM entity, we can attach up to 10 policies, not more than 10 policies. Okay. Okay, what I'll do is, if you need these, what I'll do is I'll save this, and maybe after the session, I'll send you all these images.
Okay, thanks.
Okay, so far all good. If you have any questions, do you have any questions?
Just about, I guess, roles, but I'm not sure if we're gonna go over that part.
Yeah. Now we'll talk about groups, and then we'll come to roles.
Okay.
Okay, so earlier we basically took an problem which was like in a company we have multiple users for management of access. Then we talked like we can create IAM users. Then we have another problem which was like how we'll be granting access to a specific resource or service. So we talked about IAM policy, right? Now let's say in a company, let's say we have multiple users having the same job role. Okay, let's say we have Dave is a system admin. Now let's say there are multiple users in the company who have the same job role, who are system admins. Okay, let's say the company has 5 system administrators. Okay, and we want those the system administrators will be having the same access to the AWS account, right? So in that case, what we can do is we can create an IAM group. Okay, we can create an IAM group, let's say system admin. And in that IAM group, we can add the users. We can add the IAM users. Let's say there are 5 users. So first we will be creating the IAM users. And then what we will do is we'll add these users to the group. Okay, first we'll be creating the users, and then we'll be adding the users to the group. And instead of attaching policies to the users, okay, so when we create the users, we attach the policy to the user. So instead of attaching policy to the user, what we can do is we can directly attach the IAM policy. Okay, we can create an IAM policy and we can directly attach the IAM policy to the group. Okay, these users will not be having any IAM policies. So we will be attaching the IAM policy to the group, and the group and the users who belong to the group will inherit that IAM policy which the group has. The users in the group will be inheriting the policies which the group has. So it basically makes the management of the users easy. Okay, access management basically very easy. Now let's say you want to revoke the access of all the users in the group. So instead of going to all the users and detaching the policies, we can directly revoke the access from the group. We can detach the policy from the group, and automatically all the users which belongs to that group, the access will be revoked, right? Okay, if we go to the console, okay, so here we'll create one group. Let's say for system admin, group name, let's say system admin. And then it is basically asking us to add users to the group. So let's say we have a user Dave and we are adding the user Dave to this group. And then it is basically asking which policy we want to attach to the group. Let's say system admin. Yeah, here you can find AWS managed policy, which is job function system administrator. So this policy will be attached to the group which we are creating here, system admin, and this user Dave will also be added to the group. Also later, after creating the group, also we can add the user. Okay, so user adding is optional. Okay, after creating the group, also we can add the user. So we have created the group system admin, and this system admin group has a IAM policy attached, which is of system administrator. Now in this group we can add the users. Okay, so here you can see one user and the permission, the policy which is attached to the group. So basically groups makes the access management very easier. Okay, with groups you can easily grant and revoke access of multiple users. Okay, so in group basically we add common users. Okay, like all these, let's say all these users are, let's say the company has 10 system admins. So what they can do, they can create a group and add all the system admins to that group, and then access management they can do at the group level. They can easily attach and detach the policies at the group level. Okay, and for these users we don't have to attach any policies. Okay, all the access will be managed at the group level. And also AWS also recommends that we create groups and then grant access using the groups. Okay, instead of attaching individual IAM policies to the users, AWS recommends that we use groups. Okay, do you have any question?
No.
Okay, now let us talk about IAM admin. Okay, this is one of the best practice of AWS, which is creating an IAM admin, IAM administrator. Okay, Who is IAM administrator? The IAM user who has full access to all the services and resources in AWS. Okay, the access level of an IAM administrator is same as a root user. Okay, but there are some differences between a root user and an IAM administrator. Okay, for IAM administrator, basically AWS offers one policy called administrative access. There is already a policy which is created by AWS called administrative access policy, which is an AWS managed policy. Okay, and with this policy, we can grant an IAM user access to all the services and all the resources in the AWS account. Okay, but there are, I mean, the access will be equivalent to a root user. Okay, the root user also has the same access. The root user has access to all the services and all the resources. And with this policy, if this policy is attached to an IAM user, the IAM user will be having the same access which a root user has. Okay, but there are couple of, I mean, limitation with this policy. Okay, or we can say differences. So a root user can manage the billing of the AWS account. Okay, billing access. An IAM administrator cannot have billing access. And root user can close the AWS account. And IAM administrator cannot close the AWS account. Okay, a root user can enable access to regions. Okay, like AWS, when AWS basically creates new regions, they basically do not enable the region. Okay, we have to manually enable some regions. Okay, like if you go to the console, right now here you will not find, let's say, barren region. Barren region is there, but let's say if you switch the region, let's say if we go to EC2 service, by default, all the regions are not enabled. Few regions are not enabled actually. So let's say if I try to go to barren, barren is in, I mean, the Middle East. So right now, yeah, this region is activated in my account. Maybe I have used this region, but let's say if I go to Africa, okay, here we cannot find the region which is in Cape Town. Okay, yeah, here it is. Yeah, so it says you have to enable this region. Okay, it is an AWS region, but you have to enable it. There are a couple of regions where we do not have direct access. We have to request AWS access to that specific region to create the resources. Okay, so this enabling part only a root user can do. Okay, only a root user can enable access to a region. Okay, enable and disable also. Okay, this only a root user can do. An IAM user cannot do these things. Okay, so to create an IAM administrator, we just need to create a IAM user with administrative access policy. I mean that the IAM user must have this policy, administrative access. Okay, do you have any questions still here?
Nope.
Yeah, so let's say to create an IAM administrator, we just need to create an user, add user, let's say IAM admin. Then management console access, rest things we'll keep it as default, which is auto-generated password and require password reset. Okay, then basically what we can do, we can also create a group and attach that policy to the group, and then add the user which we are creating now to a group. That also we can do. Or we can directly attach the policy also to the user. Let's say this policy, this is the policy, administrative access policy. And with this policy, we can call a user as a IAM administrator, because this policy grant access to all the services and resources in the AWS account. Or let's say if you already have a IAM administrator in the AWS account, or you want to create a user which has equivalent permission to a specific user in the AWS account. Let's say we want to create a user which must have equivalent privileges which user Dave has. So for in that case, basically we can go with this option, which is copy permission from an existing user. Or let's say you have already have a group and you want to add the user to a group, so we can go with this option. Or we can directly attach policy to the user. Let's say admin access policy and create user. So the user IAM admin has been created. And AWS recommends that we do not use the root user account. Okay, I mean, AWS recommends that we use root user only for billing purpose, only for, we can say, only for doing below actions. Okay, so AWS recommends if you want to do the billing, if you want to do the billing management, or if you want to close the AWS account or enable disable the regions, so for that only AWS recommends us to use the root user, which means using the email address and password which we use to set up the AWS account. Only for that, basically AWS recommends us to set up the use the root user. And for IAM administrator, basically, for other users, let's say for accessing the services or for creating the services, creating the resources. So AWS recommends that we create an IAM administrator, like we create a user with an administrative access policy attached to the user. Okay. Okay, do you have any questions still here?
No.
Okay, would you like to take a break, a lunch break or something?
Sure.
All right. Okay, so we talked about IAM users, we talked about IAM policy, we talked about different types of IAM policy, we talked about IAM groups, okay, and also we talked about IAM administrator, which is one of the best practice of AWS. And actually in the certification exam also they ask some questions around the IAM best practices. Do you know what are the best practices of IAM?
I think we had mentioned multi-factor authentication for the root user, only using the root user for billing or the other items that are only possible under the root account, such as closing the account, enabling access to regions. And that's all I got.
Yeah, these are the best practices of IAM, like which are like, first one is lock away your AWS account root user access keys. Do you know what are access keys?
So is that your password and your email?
Like no, access keys are basically the API keys through which basically we access the AWS CLI. Okay, so AWS doesn't recommend us to use the access keys of root user, because with that, if let's say if a user gets access to that, the user can do anything in the AWS account, right? Then create individual IAM users instead of using the root user credentials. So AWS recommends us to create individual IAM users. Use user groups to assign permissions to IAM users. Okay, so AWS recommends that create a group and then add users to the group and attach the policy to the group, right? Then grant least privileges. Okay, grant least privileges, it means, let's say if you want to create a user, you want to grant user to access, let's say create a EC2 instance, okay, or manage the EC2 service. So it is recommended that we only give access to the resources or the services which are required for the user, no additional access to any of the services or resources. Then get started using permission with AWS managed policy. So we can also use the job function policies, which we saw. So AWS recommends us to use job function policies. Then validate your policies. Validate policies, basically simulating your policies, policy simulation. Okay, AWS basically provides policy simulation by which basically that is used by security auditors to check what a specific policy is granting access to. Then use customer managed policy instead of inline policy. So AWS recommends that we use customer managed policy instead of using inline policies. Use access level to review IAM permission. Okay, this means basically, yeah, so here basically AWS is recommending us to use the access level. Access level, basically it means like what service basically we are granting access to and what action we are granting access to. Then configuring a strong password policy. Okay, so in AWS IAM, basically we have in account settings, basically we'll find password policy. Okay, so AWS basically recommends us to keep a strong password policy. So let's say I'll delete this one. So AWS recommends us to create a very strong password policy. By default, this is the default password setting, like 8 characters. And yeah, so AWS basically recommends us to keep a strong password policy, let's say of 20 characters. Then one uppercase required in the password, one lowercase required in the password, one number required in the password, one alphanumeric character required in the password. Then enable password expiration, which means after 90 days, the user will be asked to change his password. Then password expiration require administrator reset, which means if the user's password is expired after 90 days, so the user will be asked to change his, the user will not be able to change his password. He has to request the IAM administrator to change the password of that IAM user. Then allow user to change their own password. With this setting, the user will be allowed to change their own password. Then prevent password reuse. Okay, let's say after 90 days the password is expired, and then let's say if the user is asked to change his password, and if the user is keeping the same password which he had earlier, right? So that also we can prevent. So it will remember 5 passwords. So like 5 old passwords will not be able to set. So AWS recommends us to have a strong password policy. And this is the password policy. This is basically, we are talking about the console password. Okay, when we log into the console, this password, that policy we are basically talking here. And when the IAM user will be setting his password, so he has to create the password based on these parameters. If it doesn't matches these parameters, it will give an error that it doesn't matches the account password policy. Okay, configure a strong password policy for users. Enable MFA. Okay, MFA not for all the users, but AWS recommends we enable MFA for the root account, for the root user, and we enable MFA for IAM administrators. Plus, we enable MFA for the users who have full access to a specific service. Okay, or let's say a user who has a specific job function. Let's say we have an IAM user who has administrative access policy or a system administrative access policy. So AWS recommends that we give AWS recommend that the IAM user must have MFA enabled, because the user has full access to a specific services and resources. Do you know how to set up the MFA?
Yes. So I did it with an app on my phone, but I think you can
Yeah.
do it.
Yeah. So let's say we have a user Dave, and Dave, let's say, is a system admin, and Dave has administrative access policy, system administration policy, which grants full access to couple of services. So we'll go to security credentials, then assigned MFA device. By default, it is not enabled. You need to enable it. So there are a couple of ways to set up the MFA. The first way is by virtual MFA device, which is basically downloading an application like Google Authenticator, Microsoft Authenticator, or Authy in our mobile application. And we just need to scan some barcodes, and then the MFA is set up. Another way is UTF key. UTF key is basically a hardware, it's basically a USB device, and that basically generates the MFA code. Okay, that, sorry, it doesn't generate the MFA code. It basically, that UTF key, we need to, at the time of logging to the AWS account, we have to connect to our system in order to log into the account. Here you can see it looks something like this. Okay, this also provides two-factor authentication. So at the time of logging into the AWS account, if this key is attached to our machine, then only we'll be able to log in. And the third way is hardware MFA device, which is Hamilton token. So this basically generates a MFA code. Yeah, something like, yeah, like this it looks, and it generates the code. And that code basically we need to provide in the at the time of login. If we configure the MFA with Hamilton token. Okay, so the easiest way is virtual MFA. For at least for IAM users, we can use virtual MFA. For the root account, it is recommended that we use UTF or other, or Hamilton token, because those are more secure way to log into the AWS account. Also, one more thing to note here is, in terms of the certification exam, is that we cannot set up multiple ways for multi-factor authentication. Let's say if we have set up with virtual MFA, so we cannot set up with UTF key together. Okay, in combination we cannot set up. We can set up one at a time. So if we have set up virtual MFA, then it will work for, the two-factor authentication will work with virtual MFA. In order to enable UTF, first we have to remove the virtual MFA and then enable UTF security key. So here we'll click on continue. Then here it basically will ask us to scan a code, scan a barcode. So, and for this basically we need to install an application called Google Authenticator. Which mobile device are you using?
Google Authenticator.
Yeah, Google Authenticator or Microsoft Authenticator, that we need to install in our device, and then we need to scan this barcode. And once we scan this barcode, it will start generating the MFA codes. One second, my phone was switched off. Okay, you need to scan it, and then it will start generating the MFA codes. And we need to type here, we have to give the two MFA codes, two unique MFA codes, which is generated in the mobile device. Okay, so MFA is now set up. So at the time of when the user will be logging into the AWS account, he has to provide the MFA code at the time of logging into the AWS account. The user has to provide his password plus the MFA code to log into the AWS account. So AWS recommends us to set up MFA for at least for the root account and for the users, for IAM users who have full access to a specific service. Then use roles for application that run on Amazon EC2. This we'll talk later when we'll be talking about EC2 service. Then use roles to delegate permissions. Are you familiar with IAM roles?
I'm a little shaky on IAM roles.
Okay, so basically with IAM roles, what we can do is we can grant access to multiple services. Let's say if we go here in the console roles, with IAM role basically makes it possible for AWS to interact with some other AWS service. Okay, let's say we want to grant, actually it allows AWS to take action on our behalf. Okay, let's say we want to create an IAM user in our AWS account, and that should be created by the AWS account automatically when an event will occur. Okay, we can create a cron job in CloudWatch, and when a specific event will occur, it will trigger some action. Let's say we want to create a user in that case. So we can create an IAM role and grant access to CloudWatch. Do you know CloudWatch?
Yeah, CloudWatch is the log
Monitoring service.
Yeah.
Monitoring and logging service of AWS. So it basically allows AWS to take actions on our behalf. Okay, right now we are only talking, right now I don't have much example to give because right now we are starting with IAM. Later, when we'll be talking about EC2 S3, there will be a couple of use cases to get much better understanding and clearance on IAM roles. Okay, then use roles to delegate permission. Okay, this is not part of the certification exam, just for knowledge. So AWS basically recommends that, let's say in an organization there are multiple AWS accounts. Okay, so instead of creating users for all the AWS account, let's say we have two AWS account. The company has two AWS account. One is, let's say, dev account and one is test account. Now there is one user, let's say Dave, and Dave is the admin and he wants to manage both the accounts. So instead of creating user Dave in this account and user Dave in this account, we can use IAM role, IAM assume role. This concept is basically called IAM assume role. Okay, so in this case, what we'll be doing, we will be creating an IAM user in one account, and then the user will be assuming a role, and with that role, basically you will get access to this account. Okay, not only this account, with that basically the user can get access to multiple AWS accounts. So the access management also becomes easier with IAM assume roles. Do you have any idea about assume roles?
No.
Yeah, so with assume roles, basically we grant access to multiple AWS accounts without creating any additional IAM entity in other AWS account.
So is the user is created within the organization and is then given the assume role to log into whichever accounts.
Yeah, actually in assume role also we need to create a policy, and that policy basically will be granting access to other AWS accounts. And actually in the destination account also we need to create a role. That role basically will grant access to the to this account. It will grant access to this account to assume the role.
So the role, where is the role? You said the role is created within each individual account, and then
Yeah, it will be created in both the accounts. All the accounts it will be created.
okay, and
One
then
account will be granting access to some, let's say, account B, and account B will be like whitelisting that account. That user, that account will be having access to this account. Yeah, this is not the part of certification exam. Just once.
okay,
Yeah, like something like this. Yeah, dev account, we want to grant access to some, let's say, production account. They haven't given like the roles which will be creating, but yeah, I am role, assume read, cross account access.
okay.
Okay, do not share access keys. That is just a recommendation. I do not share the access keys. Access keys are basically the API keys. Like when we create the user, let's say if we are creating the user with, let's say we are creating user John with programmatic access. Okay, programmatic access means CLI access. So if we'll be creating with programmatic access, the permission, okay, let's say we are attaching administrative access policy. So when the user will be created, the access key and secret access key will be generated. Unlike when we create a user for the management console, so only password is generated, right? And in this programmatic access keys and secret access keys are generated. These are basically the API keys through which, using the AWS CLI, we can authenticate with the AWS account. Have you worked with the AWS CLI?
A little bit, yes.
Yeah. So which operating system do you use?
As far as
I mean, in your laptop, which operating system you have?
Mac.
Okay, so in Mac also we have, you have terminal, right?
Yes. Well, yes. iTerm is the one that I use.
Mhm. Okay, in Mac we install AWS CLI by this command, like brew install AWS CLI, right? Also, actually, in the official documentation, we can get the steps. Let's say if we go to this site, aws.amazon.com/CLI. So they will basically give guided steps for installing for Windows, Mac OS, Linux. Okay, for Mac OS, they are basically downloading a PKG file. Then you have to install that PKG file by brew. Or actually, with brew itself, we can get brew install AWS CLI. That should work. And in Linux, right now I'm using in Linux. So in Linux, basically we need to run this command: sudo apt install AWS CLI. Oops. Yes, right now in my machine it is already installed. So it says AWS CLI is already installed. Okay, I'm just creating one user to use for AWS CLI. Okay. Okay, so after installing AWS CLI, then we have to, just to validate whether AWS CLI is installed or not, we can run this command, AWS version. Oops. AWS -- version, which will give this output, and this output basically ensures that AWS CLI is installed in the machine. Okay, it is showing AWS CLI 2. AWS CLI 2 is the latest version of AWS CLI available. So when we log into the AWS account, so we basically provide the IAM user credentials like username, password. So the same way we have to do in the AWS CLI. So to log in to the AWS CLI, first we have to run AWS configure. And with AWS configure will be asking us the access key ID and the secret access key that is generated here. And one more thing, these keys are generated only once. Okay, so it is recommended that we download it. Okay, we cannot regenerate it. Let's say if we have lost the key, we cannot regenerate it. Okay, the only option is that we have to delete it. We cannot regenerate the key once it is generated. Okay. Oops. Copying access keys, then secret access key, then the region name. Do you know these region codes?
Yes.
Yeah, so it basically asks the access key, secret access key, and it also asks for the region code. Okay, and there are, yeah, here we can see the region names and region codes. All the region basically has a code. So in the AWS CLI also we need to tell in which region we want to work in. Okay, or in which region we want to create the resource. Then we have output format. This is actually something which is asked in the certification exam, like what types of output format we have in AWS CLI. One is JSON, and this is the default. One is text, third is table. Okay, so AWS CLI basically has these three output formats: JSON, text, and table, where JSON is the default output. Default output means basically when we'll be running any command, when we'll be querying, connecting to the AWS account, and let's say we are listing the users in our AWS account or creating any resource. So by default, it will be giving the output in any of these formats. Okay, and this format also we can configure at the time of setting up the AWS CLI. Let's say table. Now let's say AWS IAM list users. So it will basically give the output in tabular form. Okay, so here it is basically giving the API name, list users. Then it is basically showing the user ARNs, when the user was created, when the password was last used, the path, the user ID, and the username. Okay, now these commands. Okay, in the certification exam, the commands will not be asked, but just for your knowledge. So first, basically we used to use AWS, which is the prefix. Now the second thing is the service name which you want to work with. Let's say you want to work with EC2 service, so EC2. Then the action which you want to perform. Let's say you want to list instances, create instance. Okay, now these actions, okay, there is a very easy way to get all the actions. So we can go to this site. It is CLI reference. And in this site, you scroll down. So you'll find all the available service, all the services which we have in AWS. So let's say we want to work with IAM. Okay, we can choose any service, it doesn't matter. Let's say IAM. Let's say we want to create an IAM user. So first we will, in this CLI reference, we'll choose IAM. Then what action we want to perform? We want to create an IAM user. So here you will find available commands. Now let's say we want to create an IAM user. So here you will find, let's say, create group action, create role, create user. Okay, here you will find what is the synopsis, like how you can use the command, what are the parameters you can use with the command, what each of the parameter means. Plus, you will also get an example, like how to use that command. Everything you will get. So this is the command to create an IAM user. So we don't have to remember any of the commands. We can get all by the documentation. Yeah, so here you can see Bob user is created. Now, when I run this command list users, earlier it was 3 users. Now, if we hit enter, user Bob is also created. 4 users we can see. Plus, in the console also we can see the user. Okay, here you can see user Bob has been created. So all the stuff which we do using the AWS console, we can do using the AWS CLI. Okay, except the billing and closing account, those things we cannot do using the CLI. All the tasks which are related to services and resources, we can do using the AWS CLI. Okay, one more thing which can be asked in the certification exam is, which Python library does AWS CLI use?
Is it pip?
Boto 3.
Oh, I have never heard.
Yeah,
It.
pip basically we use to install pip install Boto 3 for installing the module. Boto 3 is basically, we can call, yeah, it's not a module, it's more a library. Okay, so we use Boto 3. AWS CLI use Boto 3 for running all the commands. Okay, and AWS CLI is basically written in Python, and it uses AWS Boto 3 to query AWS. Okay, do you have any questions in AWS CLI?
No.
Okay, then do not share rotate credentials regularly. Rotate credential, which means basically setting in password rotation. Okay, so that, let's say, that also we can do using password policy. Let's say setting a password expiration of 30 days. Okay, so automatically after 30 days, the user password will be expired and the user will be enforced to change his password. So that basically that is basically called password rotation. Then remove unnecessary credentials. Unnecessary credentials means, let's say if we are not using the API keys. Okay, we are not using the API keys, or we have some users in our AWS account which are not currently active. Okay, which are not in the organization. AWS recommends to remove those credentials, those users. Use policy conditions for extra security. We already saw the policy conditions, right? Where we can say set when the source IP is this, then only grant access to specific resources, right? And we can also set a condition of MFA also. Do you remember?
Yes.
Yeah, then monitor activity in your AWS account. Do you know how we can monitor the activity in our AWS account?
I guess with CloudWatch.
Yeah, there are 2 services.
And CloudTrail.
Yeah, exactly, CloudTrail. So we have 2 services for monitoring. One is CloudTrail and one is CloudWatch. CloudWatch is basically for resource monitoring. The resources which we have in our AWS account, we can monitor using CloudWatch. And with CloudTrail, basically we can monitor IAM activity. Any activity related to IAM we can monitor using CloudTrail, which is basically not called IAM activity, IAM API activities. Right now, all what we have done, let's say with the AWS CLI or via the console, all activities are basically tracked in CloudTrail. Okay, if we go to the console, yeah, here you can see track user activity and API usage. So it basically tracks both the activities, the console activities and the CLI activities as well. And these CloudTrail events cannot be deleted. Okay, even the root user cannot delete it. Okay, here you can see create access key, attach user policy, create user. Yeah, here you can see we created user John. Okay, user Bob also we should see. It will take some time because it takes some 5 minutes, 5 to 15 minutes to get the events here. But here we can see that API access keys were used by user John. Okay, create access key, attach.
It's every 15 minutes that it updates.
Yeah, 5 to 15 minutes it takes to update here, and it keeps logs of 90 days. Okay, any log of before 90 days will be deleted. Okay, that is basically the retention, log retention. It keeps of last 90 days. And actually, the exact number, yeah, 5 to 20 minutes, not 5 to 15 minutes, 5 to 20 minutes. Yeah, 5 to 15 minutes actually.
Okay.
Yeah. Yeah, here you can see the activity, the user Bob was created. It is just logged now. And that was done by user John. We can also filter also, like let's say we want to see all the activities by user John. So these are all the activities of user John, list user, create user. And also we can see here, like with which IP it was accessed, that information basically we can see by the AWS CLI it was accessed, what operation was performed. Okay, CloudTrail is basically for IAM activity monitoring, and CloudWatch is for resource monitoring. The resources which we are running our AWS account, we can monitor using CloudWatch, and IAM activities we can monitor using CloudTrail.
So, and when you create a trail, does that allow you to then save them longer than 90 days?
Yeah. If we create a custom trail, then basically they allow us to store it. Let's say, yeah, there we can set the retention. And CloudTrail basically, usually we, we create it for specific resources. Let's say we want to monitor the access to our S3 bucket. like who are accessing the objects which are stored inside our S3 bucket. So in those cases, basically we create the events. I mean, we create a separate trail. Okay, usually companies basically keeps 90 days, the default one only, which basically stores events of last 90 days based on some compliances. We can also download the events, and we can also send it to Athena service for visualization. Okay, then they have a video presentation about IAM best practices. Yeah. Okay, now let's talk about credential report. Do you know anything about credential reports?
No.
Okay, we can generate a credential report, and that report basically has the information. It's basically, we can say, an IAM audit report. And this report will be having all the activities of our, not activities, IAM related activities of our, or IAM related details of our IAM users. So right now we have 4 users in our account, excluding user root, where we can see usernames, user ARN, when was the user created, whether the user has password enabled. Password enabled means whether the user is a console user or CLI user. If password is not enabled, if password enabled is false, it means the user is a CLI user. Then when was the password last changed? Password last used. Password last used, it means when the user logged into the AWS account via the console. Then when was the password last changed? Password next rotation, which is set to 90 days. Whether the user has API keys enabled or not, whether the user has MFA enabled or not. It's also showing the activity of the API user, I mean the CLI user. When the user used the key, I mean the key rotation is set, when the key was last used, in which region it was used, which type of access key it is. So it is basically like a audit report, which is basically used by security auditors for auditing the AWS account. Okay, right now we have only 4 or 5 users, so we can also check by the console itself. But let's say if the company have thousands of users, then in that case, basically we generate this report for auditing. Okay, do you have any other question?
No.
Okay, do you have any idea about identity providers?
No. Oh, is this like if you were using login with Google or Facebook or?
Exactly. Yeah, it's like OAuth authentication, or we can say single sign-on. Okay, like let's say we have, which usually company does. Let's say they have some user management. I mean, identity provider in their organization. Identity provider like Active Directory. Active Directory is very popular. I mean, almost all the enterprises basically use Active Directory. Are you familiar with Active Directory?
No.
Active Directory is basically for user management. It is basically installed in Windows Server. So with that, basically we perform user management. In companies, basically they use Active Directory to manage access of users. Okay, and there are 2 things very popular, which is one is Active Directory and another is LDAP. Okay, LDAP is basically used in Linux operating systems. Okay, and both of these softwares are basically created for user management. With LDAP, with Active Directory, basically we can perform user management. Okay, so what companies do when, let's say, an employee joins the company, so they basically create a user account in Active Directory. Okay, let's say user one at, let's say, xyz.com. Okay, so, and with those credentials which are created in that in that Active Directory server, with those credentials, basically the user can log in or can access other resources in the company. Let's say the email account, or let's say if the company has, yeah, email account or Office suites, or let's say OneDrive or Outlook, which they have. Okay, those things basically the user can access with those credentials, and the access is single sign-on. Single sign-on means once they are logged into the Active Directory, they can log into all the other resources without any restriction, without, I mean, without having separate credentials for other resources. They can log into the AWS account, not AWS account, to other accounts, let's say Gmail, or not Gmail, Outlook, OneDrive, or some other tools which supports single sign-on. So the same thing basically we can do using identity providers. If the organization has Active Directory, so they can connect their Active Directory to AWS. So let's say if an organization has 10,000 users, and if you want to grant those 10,000 users to your AWS account, the first thing is you cannot create 10,000 users. We cannot create more than 5,000 users, right? So the company, what they will be doing, they will be integrating their Active Directory, which already has those 10,000 users, with AWS using identity providers. So in identity provider, basically they have to generate a SAML document, and that SAML document is generated by the Active Directory. Okay, here you can see, such as Shibboleth or Active Directory Federation Service. So that document they have to generate and they have to upload here. And once that connection is established, so then the users which are using Active Directory and the on-prem will be able to log into the AWS account.
Okay, so if you have over the limit, which is the 5,000 limit, but you use Active Directory, you can then have the 10,000 people able to access under the same account at that point. It's just managed where it's managed in the Active Directory as opposed to within IAM.
Yes, exactly.
Okay. Cool.
Okay, so in terms of the certification exam, in terms of IAM, now we are good. Do you have any questions in IAM? IAM roles, we have one topic left, which is IAM roles. We'll discuss IAM roles when we are familiar with EC2 and S3 service of AWS. Okay, that will bring more clarity to understand IAM roles.
Okay.
Okay. Other than that, do you have any question in IAM?
No.
Okay, sounds good. Also, I will be sharing one book with you. That book will be having around. Do you have any sample test papers?
Test papers? No.
Test papers relate like to. Okay, I will be sharing one book. That book that is an official book of AWS, which has some practice questions, which was actually published by AWS in 2019, and almost 50-60% of questions basically comes from that book. Okay.
Great.
So that is basically good for practicing. It has around 1,000 plus questions.
Great.
Okay, now we'll be starting with EC2 service of AWS. Okay, EC2 stands for Elastic Compute Cloud, and EC2 is basically a compute service of AWS, and EC2 is also called the backbone service of AWS. Okay, EC2 is also called the backbone service of AWS. Okay, not only in AWS, if in general, if we talk about cloud computing, so all the cloud computing softwares or platform basically has one core, some core services. Okay, so EC2 is basically a core cloud computing service. Okay, if we talk about cloud core services, which are basically common in all the cloud providers. Okay, even if we set up a cloud, let's say if we set up a cloud environment using VMware or some other softwares which are basically used for setting up cloud, so there are some core services in cloud. Like compute, network, database, storage. Okay, these are some core services. Core services, these services you will find in any cloud computing platform. Okay, if you go to Azure, GCP, these are common services. Okay, so in AWS we have the compute service as EC2. Okay, and when AWS started, and long back in 2006, they basically started with EC2. They started offering EC2 service. Okay, and EC2 is also called the backbone of AWS. Okay, it is also called the backbone of AWS. Do you have any idea about EC2?
Yes, they're highly configurable virtual servers.
Mm-hmm. Yeah, so in EC2, basically what we do is we provision servers. Okay, when AWS started long back in 2006, distant history, like they started with Linux servers. They started providing Linux server, which means you will be only able to launch Linux EC2 instances back in 2006. And after that, in 2010, they introduced Windows Server. And in 2020, they introduced Mac. Now in AWS, we can also deploy a Mac instance. The server will be having Mac installed. Okay, this is introduced just last year in 2020, and by 2010 they actually added Windows. And when they started with EC2, they only had Linux servers. Later, they in 2010 they add Windows, and by 2020 they added Mac. Mac will not be asked in the certification exam because it is just released. I mean this, and actually it's not available in all the regions. It's only available in a couple of regions, 5-6 regions only it is available. But right now in EC2 we can launch Linux server, Windows server, and Mac OS as well. Okay, do you have any idea about virtualization?
No, I don't think so.
Okay, cloud is basically working based on virtualization. If there is no virtualization, there is no cloud. So when we create a instance, when we create a VM in the cloud, in AWS or in any cloud, so that VM is running on a physical hardware. That VM is running on a physical hardware, which is also called bare metal. Which is called bare metal. Okay, and on top of bare metal, there is one thing which is called hypervisor. You know hypervisor?
No.
What the hypervisor is basically a software which provides virtualized environment. Have you used VMware or VirtualBox?
No.
Or have you created a virtual machine in your laptop ever?
Mm-mm.
Okay, so like we have softwares like in the market like VMware, we have VirtualBox. These are all hypervisors. Okay, we just install this software in our laptop, and with this software, basically what we can do is we can create virtual computers in our laptop or desktop itself. Okay, so the same concept is basically used in the cloud. There is a very big hardware, and that hardware we install a hypervisor, which is basically a software. And with that hypervisor, basically what we do, we spin up virtual machines. We spin up virtual machines, which is running on a hardware, on a bare metal. We can assume this is one laptop, and in that laptop we have installed a hypervisor like VirtualBox or VMware, and with that software we are basically creating virtual machines or virtual computers. These computers will be having their own RAM, own CPU, own storage. Okay, and these systems will be isolated to each other. They will be isolated to each other, plus they will be isolated to the host operating system. Okay, in case of laptop, it will be isolated to the host operating system as well. So the same concept is basically used in the cloud. So in the cloud, we have bare metal servers. Okay, do you know what are bare metal servers?
So those are the physical servers, the physical machines.
Yeah. Physical servers, which have a lot of resources. Lot of CPU, lot of RAM. Basically, each of the servers have hundreds of GBs of RAM and storage in petabytes. Okay, so in this on the bare metal, basically we install hypervisor. Okay, now there is one question which is asked in the certification exam: which hypervisor does AWS use? Which is the hypervisor software AWS uses? So AWS uses Zen hypervisor. Okay, AWS use Zen hypervisor. So all the EC2 instances which we spin up, so all these EC2 instances are basically running on top of Zen hypervisor, and Zen hypervisor is running on top of the physical server, which is the bare metal server. On top of that, we have Zen hypervisor. Okay, it's not completely Zen hypervisor, it is customized Zen hypervisor. And on top of that, we have our EC2 instances running. Okay, on top of that, we have our EC2 instances running. So EC2 is all about creating servers. Okay, servers for hosting our applications. Okay, servers for hosting our application. And currently in AWS, we can provision Windows, Linux, and Mac operating systems. So first we'll start with a Linux instance. So here we'll just click on launch instance. So let's say we have a hardware. Let's say we have an empty laptop. That laptop doesn't have any operating system. Have you done an operating system installation?
No.
Okay, so let's say when let's say a company publishes a hard laptop, so by default there is no operating system installed in that hardware, okay, in that laptop. So basically what we do is we install an operating system. Okay, so here basically we are doing that only. We are choosing the operating system here. Okay, on the hardware, which operating system we need. And these operating systems in the cloud, we call it as AMIs, Amazon Machine Image. Okay, and these are basically operating systems. Okay, here in the cloud, we do not perform any installation. Okay, we do not perform any installation. Like when we install an operating system, so at the time of installing an operating system, we choose which hard disk to use. I mean, what partitions we want to create in the operating system, like how much disk, what will be the disk size that we have to select. But here we are not doing any partitioning, or we are not doing any installation here. We are basically deploying an operating system. Okay, like in general, let's say in school, colleges, or in large enterprises, let's say there are thousands of computers. And in those thousands of computers, we have to install an operating system. So let's say if we start installing from one machine, we basically need a bootable DVD or a USB to perform the installation, right? If we start doing the installation, let's say if one machine is taking 30 minutes. So if we see if there are 1,000 machines, so it will be taking almost 3-4 days or a week to do that for thousands of computers, right? So instead of that, basically what we do is we create an OS image. Okay, OS image, it's also called system image. And in cloud, basically we call it as cloud image, which is basically in AWS is called an AMI, Amazon Machine Image.
So the AMI is both the operating system image and the system image?
Yeah.
Okay.
And these operating system has the OS is already installed. OS is already installed, drivers are already installed. Like when we install an operating system, we have to install the drivers.
And what are the drivers?
Drivers, let's say audio drivers, graphic drivers. Okay, drivers are basically an intermediate between the software and the hardware.
Okay.
Okay, drivers we need to install, and okay, and in AWS these images are cloud optimized. Cloud optimized, it means these operating systems are optimized to run on AWS hardware. Okay, these operating systems are optimized to run on the AWS environment. Like the kernels are tuned. Okay, like operating system basically has a kernel. Okay, which basically interacts with the hardware. Okay, so the kernel is tuned based on the hardware of AWS. Some softwares are already installed. Okay, this is basically an AMI. This is basic. These are all things basically an AMI has. It already has the operating system. It already has the drivers installed. It is already optimized based on the cloud environment. It has some softwares already installed. So installation is already there. So let's say this is an AMI. So we use this AMI to deploy an EC2 instance. With this AMI, basically we create an instance. Okay, and a Linux instance. Let's say when we are deploying a Linux EC2 instance, so it comes in running state within 10-15 seconds. Okay, it comes in running state in 10-15 seconds. And whereas, let's say if we would be doing the installation of any operating system, it will take at least 10 minutes to an hour. Okay, if you will be installing Windows operating system, it may take 1-2 hours to do the installation. On Linux, it may take 10-15 minutes. Okay. But here we are not doing any kind of installation. We are just deploying the operating system where that operating system drivers, softwares are already installed. Okay. So that is basically what we call a image. Operating system image, this system image, or a cloud image. All these terms are same. Okay. And this image has already the operating system, some drivers, some softwares. Okay, we can also create our own image. Okay, later in the course we'll see how we can create our own AMI. Okay, by taking this as a base AMI, base operating system, we can create a customized AMI, which will be having set of softwares we need, a set of customization which we need for our environment. So here you can find all the AMIs like Amazon Linux. Okay, this is basically an operating system which is created by AWS. Okay, to run on their platform. Most of the companies who are using AWS, they basically use Amazon Linux because it comes with 5-year support of Amazon. So most of the companies basically rely on Amazon Linux if they are using AWS. Okay. Then we have Mac operating system like Mac, Big Sur, Catalina, Mojave. Red Hat Enterprise Linux. Okay, like companies on-premises, if the companies are using Red Hat operating system, if they have Red Hat license, so they can also use Red Hat Enterprise Linux. It is basically meant for server security and it comes with Red Hat support. And SUSE Linux Enterprise Server. These are all operating system. Ubuntu Server. Ubuntu Server is another common we use operating system in the market. Windows Server 2019. This is the latest Windows Server operating system available in the market. Debian. Okay, so there are a lot of AMIs which are created by AWS. Now, depending on our use case, depending on what application we want to run, depending on that, basically we choose an operating system. We choose an AMI. Okay, so here at the left side you can find Quick Start. In Quick Start you will find some of the very popular and generally used AMIs. Then you have My AMIs. Okay, later in the course we'll see how to create an AMI, and those AMIs, when we create our own AMI, those AMIs are listed here. Then we have AWS Marketplace. Here we can find some standard AMIs. Standard AMIs which are created by some organizations. Okay. As we discussed, AMI is basically has the operating system installed, it has drivers installed, it has some software installed, right? So when we deploy an AMI, when we deploy an instance with an AMI, okay, let's say when we are deploying an instance with this AMI, so this instance will be having all these things already inside it. It will be having the operating system, it will already have the drivers, it will be cloud optimized, it will be having some software already installed in it, right? So the same thing what company does is like they create their own AMI, and that AMI basically has the software already installed. Let's say here you can find AMIs for infrastructure software, DevOps, business application, machine learning, IoT, industries. Okay, let's say you want to look for backup and recovery softwares. Here you can find NetApp. NetApp is a very popular company. They have created their own AMI with their software already installed in it. Common Vault. This is also a very popular company, Common Vault. So here basically we'll find some operating systems which have some software, some popular software already installed. Like the companies which are product based, which basically have created their own software, which they basically sell on license basis or on free basis also. They have created their AMIs and they are basically selling those AMIs on AWS. And when we deploy the instance with that AMI, it will have that specific server, specific application software already installed. Okay, and let's say if the application has some licensing. So basically, they also offer two types of AMI. One is with, let's say, if we are launching the instance with the license one, then it will be having the license also already installed. Let's say if we deploy a Microsoft Windows server, okay, and Windows server, which it means it basically requires a license. So let's say if we'll be deploying this instance, so this instance will also come with a license. Okay, the license will be also installed in it. But in that case, AWS will be charging us additional cost for that. Okay, here you can find CentOS, which is officially given by CentOS organization. OpenVPN. OpenVPN is a very popular software. Debian operating system, which is officially provided by Debian. Red Hat Enterprise Linux 7. Here you can see firewall, Palo Alto firewall. Here you can see AMI with AMI of two types. One is boiled and ELA. ELA is basically, it means it will come with license. If it is of boil means bring your own license. Let's say if your company on the on-premise already is using Palo Alto Network firewall and they already have the license. So they can spin up an EC2 instance here with this AMI and they can provide their license. Then we have community AMIs. So these are the AMIs which are created by people like us who have an AWS account and they have created their custom AMIs and they are they have made those AMIs publicly accessible. And once we make a AMI publicly accessible, the AMI will be listed here. Okay, when we create an AMI, we can create that AMI as a private AMI and as a public AMI as well. So if we are creating it a private AMI, so it will be only accessible in our AWS account. If we make it publicly accessible, then it will start listing here in the community AMIs.
And people can charge for these, correct?
Yeah, actually AWS will charge us for this depending on the no, community AMIs are free. Let's say if we deploy an instance with any of these AMIs, so we'll not be we don't have to pay any additional charge.
Okay.
But if we are using this marketplace AMIs, so for each of the AMIs there is additional charges.
Okay.
Yeah, here you can see starting from 30 an hour, 30 cents an hour, from $1,600 a year. So there are additional charges for marketplace AMIs, whereas community AMIs are free to use.
Okay.
Are you familiar with the free tier plan of AWS?
Yes.
Yeah, so with free tier, basically AWS basically provides free access to some specific services and with basically a limit. Okay, so in EC2, basically AWS provides access to T2.micro instances, and some of the AMIs, they are providing free access for 750 hours a month. Okay, so let's say if we are running one EC2 instance for 750 hours in a month, so we'll not be charged for that. Okay, so we'll go with Amazon Linux. The next thing is instance type. Instance type, we can also call it as an hardware template. So instance type basically describes what will be the resources in our server. Like what will be the RAM, what will be the CPU. Okay. Now, depending on our use case, depending on our application, basically we have to define here what will be the resources we need to use.
Okay. And RAM is the memory, while CPU is like the computing power.
Exactly, exactly.
Okay.
So CPU, we can say like the Intel processors or Intel Xeon processors. Intel Xeon processors are data center processors. Okay, which are basically here. Basically, we are basically telling on which hardware, which type of hardware we want to launch the instance. Okay, if we go here. Yeah, so there are instance type like M4, M5, M5, and T2, T3. So each of these basically are categorized based on the hardware. Okay, each of them are basically using Intel Xeon processors, but each of these processors have different computing powers, different computing, different like limitations. Like compute optimized, highly scalable processors, memory optimized, accelerated computing, storage optimized processors. Okay, so these are all hardware types. Yeah, so this is, let's say if we are launching an instance of M5, M4, sorry, so it will be running on top of this processor. Okay, and each of these processors basically have a clocking speed or processing speed. So here basically we are choosing the hardware. Now depending on our needs, like depending on what application we are running, or depending on what will be the traffic on the application, depending on that basically we choose an instance type. So let's say if our application, we want to deploy a web server with, actually depending on the application, we can get the system requirements. Each of the application basically have some system requirements, like at least this much resources must be there in the on the server where we are running the application. Are you familiar with any application like WordPress?
Yeah.
Okay, WordPress is a very popular, I would say, CMS. Okay, it's also a web application. It's basically a CMS with which almost 70% of sites on the internet are running on WordPress.
Wow, I did
Okay,
not.
with WordPress, sorry.
Oh, nothing. Go ahead.
Yeah, with WordPress, basically we can easily create blogs and websites. Okay, because in WordPress we don't have to do the coding; it's just drag and drop. So almost 70% of the sites on the internet are using WordPress. Okay, so based on the application requirement, basically we'll get the instance type. Okay, so we'll go with T2.micro, which comes under the free tier plan, which comes with one CPU, one virtual CPU, and 1 GB of RAM. Okay, and depending on our use case, we have a lot of other instance types. Okay, we can even get a server with 3 TB of RAM, 3 TB of RAM, 128 cores of CPU. This is a very big server. 128 cores of CPU, and almost around 3 TB of RAM. Depending on our compute needs, like blockchain server basically require a lot of resources, a lot of compute resources, CPU and memory resources. Okay, then here we have to give number of instances we want to launch. Other things we'll talk later when we'll be talking later about other things. Let's say networking, which is basically completely separate service of AWS, which is VPC. Okay, so here we'll keep it as default. Here we'll just talk about this for now, which is number of instances we want to deploy. So by default, it is set to 1. So what it will be doing, it will be deploying one EC2 instance. And let's say if I set it to 5, so it will be deploying 5 EC2 instances with this AMI and of this type, t2.micro. Okay, if you want to deploy multiple servers together of the same configuration, so here we can add number of instances we want to deploy of the same configuration. So for now, we'll go with one instance. The next. Now here basically we have to define the storage. Okay. So here storage, like here by default it is set to 8 GB. Okay, 8 GB is basically the size of the AMI. Okay, so we chose AWS Amazon Linux AMI. So Amazon Linux AMI is basically installed in 8 GB of disk space. That's why basically they have given us by default 8 GB. We cannot decrease the size. Okay, let's say if you want to create less than 8 GB, we cannot do that because in 8 GB the operating system is installed. Okay, and this disk is basically called a root disk. Okay, there are basically two types of disk: root disk and data disk. Root disk is the disk where the operating system is installed. Okay, also it is called a boot volume. Okay, because from that disk the operating system basically boots, right?
So the root disk is where the operating system is installed and where it boots up.
Yeah, exactly.
And what was the other type of disk?
Data disk. Data disk.
Okay.
Data disk is basically dedicated for storing the data.
Okay. And
Whereas root disk is where the operating system is installed. And it is recommended that we, let's say if you want to store data in your EC2 instance, so it is recommended that we create a separate disk. Okay, and this disk is basically data disk. And in this disk, basically, it is recommended that we store our data. One is the root disk. Root disk is also called a boot disk. And one is data disk. In root disk, the OS is installed. And the reason why it is also called boot disk is the OS boots from that disk. That's why it is also called boot disk. And data disk, it is a raw disk which we use for storing data. Okay, the primary use of data disk is to store data. Okay, in this root disk, we do not store data. We can store the data in this disk also, but the problem is, let's say if the operating system crashes. If the operating system crashes, so the data which is stored inside the root disk will also be lost, right? Whereas in data disk, it is just a raw disk. Even if the operating system crashes, the data will not be affected. Okay, so it is recommended that for storing data, we use data disk. So the first disk is basically the AMI, and in this disk, the operating system is installed, and this is also a boot volume because the operating system will boot from this volume. So we can increase the size, but we cannot decrease the size. This is the default size. Okay, and depending on the AMI, this size keeps on changing. For Windows, the minimum size is 30 GB. Okay, it completely depends upon the AMI. Okay, then later we'll be talking about what are volume types. We'll be having a discussion dedicatedly on volumes. Here we'll be talking about different types of volumes. Tags we'll discuss later when we are familiar with RDS and VPC. At that time, we'll talk about tags. Then we have security groups. Are you familiar with firewall?
Yes, so it's where you create rules that allow traffic in or out of your instance based on the rules that you create. Is that about it?
Yeah, firewall basically manages the network traffic. Network traffic at the incoming traffic and outgoing traffic. Okay, that is basically managed by a firewall. Let's say we have a server. Okay, now the requests which are coming to the server. Okay, there are two things. One is incoming request and one is outgoing request. Incoming request is the request going to the server. Request server is making outside. Okay, so the request which is going to the server is called incoming request. Incoming request or ingress, or is also called inbound. And the request which is going out from the server is basically an outgoing request, which is also called egress and outbound. Okay, which is basically an outgoing request, egress, and outbound request. Okay, yeah. So and in right now we are accessing the internet. Okay, to first let us understand what is an outgoing request. Right now we are accessing the internet. Let's say I'm going to some site. Let's say I'm going to, let's say, google.com. So when I'm going to google.com, I'm making an outbound request. From my computer, I'm making an outbound request. I'm trying to reach the Google server, right? And Google server is basically giving a response, which is this site, right? So this is basically an outbound request. Okay, we can say accessing the internet. This is basically an outgoing request. An incoming request. Let's say if someone is, let's say this is google.com server. And let's say I'm trying to access google.com server. So from my end, I'm making an outbound request. But for google.com, it is an incoming request. Okay, incoming request, which means like someone is trying to open google.com. So for Google server, it is an incoming request. For Google server, it is an incoming request. Okay, so the incoming, outgoing, this is basically managed by a firewall. Okay, this is not managed by a firewall. I mean, in terms of network security, basically we need a firewall. Okay, let's say in a server, basically we have ports. Let's say if all the if we don't have a firewall, so by default, all the ports will be exposed. and if those ports are exposed, anyone can log into the server, can basically make an access to the server. Okay, anyone can access the server. Okay, anyone can access the server. So basically what we do is we basically attach a firewall to the server. Okay, firewall is basically of two types, hardware firewall also and software firewall. Okay, basically we have two types, hardware and software firewall. So it can be a hardware firewall also, and it can be a software firewall. In software, in both of the firewall, basically the working is same. Basically what we do is we basically restrict the incoming and outgoing traffic. Okay, in most of the cases, basically we do not make any changes in the outgoing packets, outgoing requests. Okay, in incoming, basically we restrict the access by firewall rules. We create rules in the firewalls, like only access on port 80 will be allowed, or only access on port 443 will be allowed. Do you know what are port 80, port 443?
Let's see. So port 80 isn't that HTTP, and 443 is HTTPS?
Yes. So these are the two standard protocols basically which are used by a web server. Any website which we are accessing on the internet, let's say I'm accessing google.com. So google.com is running on port 443. Okay. And let's say Google is also a server. Do you know about SSH or remote login?
Yes. So isn't that like 22?
Yes. Yes. So the server basically, let's say if the server is remotely located. So for remote login, basically we use SSH and RDP. SSH is basically used in Linux and RDP is used in Windows. Okay, RDP stands for Remote Desktop Protocol and SSH stands for Secure Shell Host. SSH works on port 22, whereas RDP works on port number 3389. So let's say on every server, basically we have these services running. If it is a remote server, then basically we have this service running. So if someone is trying to log into the server by SSH, okay, if someone is trying to log into the server by SSH, so the user will be able to log in. Okay, login means the user will be able to make an SSH request to the server, but we don't want anyone to log into the server. We only want the user who is authorized, who is a server admin, who is administrating the server, can log into the server, right? So that to block such kind of request, we basically use a firewall. Okay, firewall is all about network security for blocking the access or restricting the access to a resource over a network. Okay, so in AWS, the same concept of firewall we have in the form of security groups. In AWS, we call it as security group. It's basically a firewall. It's basically a virtual firewall. So in this security group, basically we create inbound and outbound rules. Okay, in 99% of cases, we do not touch outbound rules. We only configure the inbound rules. And in inbound rule, basically we open the ports and which ports we want to open from the server. Okay, if we do not use security group or firewall on a server, so there are a lot of chances of getting the server compromised. Okay, so we use security groups. In AWS, basically we use security groups. So let's say if it is a Linux server, so we have to open port 22, which is SSH port. And with SSH, we can remotely log into a server. Okay, it doesn't matter which country or which location basically we are located. If we want to remotely log into a server, so we use SSH protocol. In Linux, we use SSH. In Windows, we use RDP. remote desktop protocol. Okay, so here we will be creating one security group. And it also depends upon what application you are going to run in the server. If you are going to run a web server, okay, if you are going to install software like Apache, which are basically used to set up a web server, so in that case you have to open port 80. Okay, also later also you can do, after launching the instance also you can do. Now one more thing to note here is that we cannot launch a EC2 instance without a security group. Okay, without a security group we cannot launch a EC2 instance, and a EC2 instance will be having minimum one security group. Okay, it will be having minimum one security group, and it can have maximum 8 security groups. Okay, to a EC2 instance we can attach maximum eight security groups and minimum one security group. An EC2 instance cannot be created without a security group. So for now we'll only allow SSH access. Later we'll be talking in brief about security group. Then at that time we'll talk more about the source, like custom anywhere my IP. Then we'll click on review and launch. So here in the review page you'll see the information like what operating system you chose, what is the instance type, which security group is attached, what inbound tools are open, what are the instance details, what is the storage. Okay, now here we click on launch. Now at the time of launching the instance, it will ask us to create a key pair. Okay, are you familiar with key pair?
Yes. So it creates a PEM file on your system. Is that right?
Yeah. So basically, it basically generates a SSH key. Okay, SSH key is basically a pair of public and private key. So when we create a key pair, so basically what AWS does is it basically generates a public key and a private key. And public key, it will upload it to the server. When the instance will be launched, it will upload it to the EC2 instance. Private key, it basically gives us to download in the form of a PEM file. Okay, so AWS basically has generated a private key. Here you can see a key pair consists of public key that AWS store and a private key that you store, which is this PEM file. This is the private key. So public key and private key, public key we can assume as a lock, and private key is a key through which we can open the lock. Okay, both of these basically matches with each other, then the connection is established, then the authentication is succeeded. Also, once we have downloaded this key, we cannot, okay, the name already exists. Also, once we have downloaded the key, we cannot regenerate the key. So we have to make sure that we keep this key safe. Okay, actually it is giving error in security group because I already have one security group by this name. Okay, here we can give a name to the instance. So Linux instance basically takes 5-10 seconds to come in a running state. Whereas if we deploy an Windows server, so it takes it takes at least 5 minutes to provision. Okay, provision, it means it will take some time to do the setup. Okay, like configuring the license, getting the user, getting the server ready to log in. And whereas a Linux instance is provisioned within 5-10 seconds, which means it is ready to log in, which means it is ready to use. Whereas Windows instance take 4 minutes to provision, at least 5 minutes to provision actually. Okay, now we'll see how we can log into the EC2 instance. Do you know how to log in?
Yes, I think you have to CD into the folder that you downloaded the PIM file into.
And
And
change the
then,
permission of the key. Change the permission of the key. I think it's not required in Mac, but it is required in Linux. You have to change the permission of the key.
gotcha. So what is, so the chmod 400 command, that is,
That is basically for changing the permission of the file. With this command, basically we are giving the owner of this file read access. And for other users, we are giving 0 access, which means nil access. So other user will not be able to access this file.
okay. Oh, gotcha. Okay, because otherwise it wouldn't allow you to log in that way if it wasn't private.
Yeah, it will not allow us to log in. Also, let's say if there are multiple users accessing our machine, so they will also gain access to that key, and they can also log into the server.
Okay.
Yeah, so log into the server, it has generated public IP. Do you know what is a public IP?
It is an IP address that can be reached via the internet.
Exactly. Yeah, it is an IP address which is reachable over the internet, or we can also say it is an IP address which is routable over the internet. Anyone who is connected to the internet can reach to this IP address. Okay, so to do SSH, we'll use the SSH command and the username. For Amazon Linux instance, or I would say for most of the Linux instance in AWS, we have default user EC2 user. But depending on the AMI, the username changes. Okay, for Ubuntu operating system, the default user is Ubuntu. And for other operating system, depending on the AMIs, we can also get this information in AMI info. Okay, if we, at the time of launching the instance, if we click on view details of that AMI, so it will give us proper information of like to log in from which user. And then the IP address, the public IP. We can use the public IP or we can use the public DNS name. Both will work. Then -I and the key. And we have successfully logged into the EC2 instance. Okay, with sudo su command, basically we can become the root user. Now, just to understand the working of security group, we'll set up a web server in this instance. So we'll use this command yum install httpd. This will basically install Apache web server in the server. Then systemctl start httpd, that will start the service of Apache. Then systemctl enable httpd, which will enable the service of Apache. And after running these commands, we should be able to access the default page of Apache, default website page. So the next step is like copying the IP address and pasting on the browser, and we should be able to see the Apache web page, the Apache web server default page. And right now we are not able to see it. Do you know the reason?
Is it? No, I don't.
It is because in the security group we do not have port 80 open. So we'll click on security.
Gotcha.
We go to security group. Right now we only have port 22 open, and hence we are not able to access our site. Here we click on add inbound rules, HTTP. Then let's say anywhere and save rules. And once we do that, yeah, so we are able to see the default page of Apache. Okay, this page is used to test the proper operation of the Apache HTTP server after it has been installed. If you can read this page, it means the Apache HTTP server installed at this site is working properly. So we have successfully installed the Apache web server. Do you have any questions still here?
This might be off topic, but I'm just wondering why we're installing a server on top of a server, like the Apache servers being.
No, Apache server is basically a software.
Okay.
Yeah, it is basically a software which we have installed inside the server. It's basically used for hosting the websites. Almost 50-60% of websites run on Apache web server. It's very old. I mean, it's very old and it's very popular in the market. Like many hosting providers like GoDaddy, HostGator, basically they use Apache web server for hosting the websites.
Gotcha.
Okay, also EC2 is a regional service. Regional service, it means we need to use, when we create a resource, it will be created in a specific region. So right now the instance which we created, it basically is deployed in Northern Virginia region. Okay, are you familiar with the concept of regions and availability zones?
Yes.
Okay, so this instance is running in this availability zone. So in each of the regions, basically we have availability zones. Okay, let's say this is a region. Region is just a geographic location. And inside a region, basically we have availability zones. And what are availability zones? Availability zones are physical data centers. Okay, let's say this is the region. Do you know the number of availability zones in Virginia?
Isn't there 8?
Six availability zones. And Virginia is the first data center, which or the first region when AWS started, they created, I mean, they started with this region, Northern Virginia. This is the oldest region of AWS. And it has the maximum, I mean, it has the most, or I would say, it has the maximum number of availability zones across all the regions. So it has basically 6 availability zones. And these availability zones are physical data centers.
Does each region have to have at least two AZs, or is it?
Yeah, minimum 2 availability zones.
Minimum
Yeah,
2.
each regions must have at least 2 availability zones. And almost all the data centers all the regions which AWS has deployed across the globe have two availability zones. And most of them actually now AWS have started making it to three availability zones for giving high availability across different regions.
So if it was a question, would the answer be 2 or 3, like if it was on the exam?
No. They will not be asking anything related to the availability zones. Even they will not be asking what is the number of availability zone in a specific region. Okay, because they keep on changing this information. I mean, they keep on extending the availability zones. Okay,
Okay.
so it's not actually static. So each of the region basically has a code, which is basically called a region code. Let's say Virginia has this code, and each of these availability zones also have a code. Let's say this availability zone, US East 1A, US East 1B, 1C, 1D, 1E, 1F. So each of these regions basically have an availability zone. Okay, and right now if we go to the console, we see this EC2 instance running. So this EC2 instance is running in this availability zone. Okay, so the instance is running in this availability zone. So when we create a resource in AWS, when we create a resource, so the resource is basically running in a availability zone. The resource physically exists inside a availability zone, which is a physical data center. So right now our EC2 instance is running in this availability zone.
Does that mean that it's running in all 3 of the data centers located inside of that?
No, it's running only on one data center.
One data center. Gotcha. So there's no like duplication built in.
Yeah, actually for that basically we use load balancers. For that, in that case, basically what we do, we deploy instances across multiple availability zones for high availability. So let's say if this region, I mean this availability zone fails, we'll be having a server in another availability zones to handle the traffic. Okay, now we'll be talking about security groups. We'll be seeing what are the limits in security group and what are the rules we can create in a security group. Okay, so we already talked about security groups, which is basically a firewall which manages the incoming and outgoing traffic of a EC2 instance. And on a EC2 instance, we can have minimum one security group. Minimum one security group. And maximum 8 security groups. Okay, so to an instance, we can attach minimum one security group and maximum 8 security groups. Okay, we can assign up to 8 security groups to an instance. Okay, also one more question can be asked in the certification exam. Like one question could be like how many security groups we can assign to an EC2 instance. So we can assign 8 security groups to an EC2 instance. Another question which can be asked is how many security groups it can attach to a ENIC. Do you know what is ENIC?
No.
ENIC is Elastic Network Interface. Okay, so
Well,
right now in our EC2 instance,
what is Elastic Network Interface?
it's basically the NIC card which is attached to our instance.
It's what card?
NIC card, NIC, Network Interface Card.
Okay.
In all our laptop, desktop, any machine who wants to communicate over the internet, or not over the internet, over a network, has a NIC card. Even in our phones, everywhere actually, the machine, I mean, any device which is connecting to a network or to the internet has a NIC card. In our laptops and our desktop, basically we have this kind of NIC cards. We have wireless NIC cards also, wired and wireless NIC card. Yeah, this is wireless NIC card. So our instance basically also has a NIC card, which is basically a virtual NIC card. And in this virtual NIC card in AWS, we are calling it as Elastic Network Interface, ENIC. We can see this here, network interfaces. Okay, so when we are launching an instance, one NIC card is attached to the instance. One ENIC is attached to the instance. Okay, one ENIC is attached to the instance. So there could be, do you know ipconfig command in Windows?
No.
ifconfig command. Yeah, so in Linux or in Mac also you will find this command, ifconfig, which basically stands for interface configuration. So here you can find ETH0. This is basically loopback virtual network interface. And this is basically ETH0. This is basically the NIC card, physical NIC card, which is attached to the server. Okay, but in our case, as we are running the EC2 instance, this is basically a virtual NIC card, which in AWS language we call Elastic Network Interface. Okay, so by this network interface, our machine, our EC2 instance is talking over the internet. Okay, talking over the internet or talking over a network. Okay, ENIC basically makes the network communication of two devices. So one question can be asked in the certification exam, like how many security groups you can attach to instance, or they can also ask how many security groups you can attach to a ENIC. ENIC, or they can also say to a network interface attached to an instance. So the answer is same. We can attach 8 security groups. Minimum 1 and maximum 8 security groups to a NIC card. Okay, to a ENIC card, Elastic Network Interface. Just to confuse, basically they can ask this question: how many security groups you can attach to a network interface?
Gotcha.
Now there are some limits in security group. Like as we know, in security group we can create inbound and outbound rules. Right? We can create inbound and outbound rules. So inbound rules, we can create up to 60 inbound and 60 outbound rules. Okay, in a security group, in one security group, we can create up to 60 inbound and 60 outbound rules. Okay, if we go here in the console, so we created one security group, which was this one, And right now in inbound, we have created 3 rules. 2 of HTTP and 1 is of SSH. And outbound usually we do not touch. Okay, outbound is open to all traffic. Okay, usually we do not make any changes in the outbound rules. In 99% of cases, we do not touch the outbound rules. Okay, because this is the network going outside from the instance. And in inbound, basically, I mean, this is basically managing the incoming request to the server. Okay, so it is recommend. I mean, the best practice is that we keep our inbound rules allowed to only specific IP addresses. Okay, so right now in inbound we have 3 rules, which is allowing SSH, HTTP, 2 HTTP access and 1 SSH access. So right now we have 3 rules, and in a security group maximum we can create 60 inbound rules and 60 outbound rules. Okay, 60 inbound and 60 outbound rules. Now source. Now when we are creating a rule, we create a I mean, in that rule basically we specify the protocol, the port number, right? Let's say when we are creating a rule, let's say add rule, so we have to specify the protocol, the port number and source. So source, basically here we have 3 types. One is custom, anywhere and my IP. Now let's say if I set it to my IP address. So right now I'm logged into the AWS account, it will automatically detect my IP address and put it here. So this is my public IP right now. Okay, when we connect to the internet, we basically have a public IP. So right now my computer has a public IP, which is basically assigned from my router or Wi-Fi. So this is my current public IP address. So let's say I am the server admin. That server I have to administer. Okay, or I want to make any changes in the server. So I'm basically the server admin. Okay, I am basically assigned to manage that server. So the access, the SSH access. Okay, SSH access is basically logging into the AWS, logging into the server. It will be only allowed to my IP. Okay, the administrator IP. Okay, with my IP, it will basically automatically detect your current internet IP and it will put here. Okay, then we have anywhere. Okay, for SSH, we never keep it to anywhere. Okay, for SSH, basically we keep it to my IP and Apache, HTTP. HTTP, basically we keep it anywhere. Anywhere means any IP address on the internet will be able to make a request to the server. Which request? HTTP request. Okay, so if we want to remove all the restriction for us from a specific port, so then in that case basically we set it to anywhere. This is public IPv4 address and this is public IPv6 address. With these addresses we are allowing access to the whole internet, and anyone on the internet will be granted access. But in this case, only the guy who has this IP address will be granted access on port 22.
So,
Whereas in this, yeah, go ahead.
when it says my IP, can you put any IP there in theory?
Yeah. If we set it to custom, then we can basically manually give the IP address.
So,
Let's say we want to grant access to multiple people. Let's say we want to grant access to multiple developers who will be working on the server. So in that case, we can put here multiple IP addresses, comma separated. Let's say 10.0.1. something. Let's say this network. Then multiple IPs. Let's say this IP. This IP. So we can give multiple IP addresses.
Okay.
And each of these IP addresses will be creating one rule. Let's say we have created one rule with 3 IP addresses. So when you will be saving, it will be creating 3 rules for these 3 IP addresses. Okay, let's say if we save this. So now we will be able to see 5 rules. Here you can see we are able to see 5 rules. Okay, for each of the IP address, it has created one rule. So right now our inbound has 5 rules. So one is my IP, it will automatically detect my IP address. One is anywhere, which will grant access to all the IP addresses on the internet, which means anyone who is connected to the internet will be able to make access, will be able to make a request. And the third one is custom. In custom, basically, we can provide manually the IP address, or yeah, in custom, basically, we can provide manual IP addresses. Okay, let's say if you want to give access to multiple IP addresses to a specific port. So in that case, we can give IP address manually. Okay, do you have any questions still here in security group?
So security group is only allow rules, correct?
Yeah, it only allows rules. We
Okay.
can only create allow rules in security group. We cannot create deny rules. Later, when we will be learning about VPC, in VPC we have NACL, Network Access Control List. There we can basically, that is also like a firewall, which works at the more at the network subnet level, with which basically we can create allow and deny rules. Whereas with security group, we can only create allow rules. We cannot create deny rules. And by default in security group, all access is denied. Okay, only we can create allow rules.
But if you don't create any rules when you first set it up, is all access?
It will be denied.
Or what's that?
It will be denied, deny access by default.
Okay.
Without any rules, it will be deny access. Yeah.
Okay. Gotcha.
Okay, so right now we have our instance running, and with this IP address, our, let's say the application is running. Okay, let's say this is the default page, and let's say we have our application running. Now let's say for some reason we have to stop the instance. Okay, let's say for companies basically do, let's say this is a development server, and let's say the developers are working from 10 a.m. morning to 5 p.m. in the evening, and after that we don't need the server, right? After that the server is of no use. The server will be back in use in the next morning when the developer will start working, because the developer is working on the instance and it is basically a development server. So in that case, what companies basically do is they will stop the server. And if they will stop the server, so they will not be charged for the server, right? Because with EC2, like when we launch a EC2 instance, and if it is in running state, so we are basically charged an hourly rate, right? Are you familiar with the pricing?
Yes.
Yeah, so depending on the instance type, there is an hourly rate. Let's say for T2.micro, there is an hourly rate. Actually, we can see here in instance types. For each of the instance type, we can see hourly rate for Linux servers and Windows servers. Yeah, let's say T2.micro. If you scroll at the right sides, so here you can see on-demand price for a Linux server is this. Oh, sorry, it's T2.small. For T2.micro, it is this 0.0162 cents per hour. Okay, so here, oh, sorry, this is for Windows and this is for Linux. Okay, so yeah, Linux one is cheap, and if we see Windows one is little expensive.
Yeah, and they don't have Mac up there yet.
Yeah, Mac actually there is only one or two instance type right now currently supported. Right now, let's say if we try to launch a Mac server, so only 1 or 2 instances type currently they support. Yeah, this one, Mac one. Other than that, we cannot use. Yeah, Mac 1.metal. Currently, they only have this 12 CPU, 32 GB RAM. Okay, so let's say we have stopped the server. So, and if we stop the server, our application will also be down, right? And if it is a development server, so it doesn't matter. Okay, so now the next day the developer comes, and developer starts working. So we'll start the server. And if we'll be starting the server, so the public IP address of the server will be changed. When we stop the server, the public IP of the server gets changed. So basically, AWS provide 2 types of IP addresses, 2 types of public IP. One is the dynamic IP. Okay, dynamic IP is the default IP. And one is the static IP. Static IP, which is also called elastic IP. We'll talk about elastic IP in a minute. So we have 2 types of public IP addresses offered by AWS. One is dynamic IP, which we can also call the default IP, which means when we are launching the EC2 instance, by default, the EC2 instance gets the dynamic IP. Right now, our instance basically has this dynamic IP, which means when the server is stopped, the IP address is released. And when we start the server, a new IP is assigned to the server. Okay, so the dynamic IP, when we stop the server, the IP address, the public IP of the server is released. And when we start it, a new public IP is assigned to the instance. So now let's say if you're running a production server and for doing some maintenance, if you have stopped the server and if you have lost the public IP, and let's say if your users are accessing the application with the public IP, they no longer will be able to access the application. So then you have to update your customers or the clients with the new IP address, new public IP, right? And let's say if you have 10,000, hundreds of thousands of customers, then it will be very difficult to do that. So in that case, what we do is we use elastic IPs. Okay, elastic IP is basically a static IP. Okay, so even when we or we can say in all instance states, the IP address is not lost. In all instance state, the IP address is not lost. What are instance states? One state is start, not start, running. One is stopped. Third is hibernation. Fourth is terminated. So in all of these states, we do not lose the elastic IP. Even if we terminate the server, then also we do not lose the elastic IP. So when we create an elastic IP, it is basically not only assigned to our EC2 instance, it is assigned to our account. It is assigned to our AWS account. Okay, it is assigned to our AWS account. So even when we delete our instance, terminate our instance, still we have the elastic IP in our account. Okay, so what we do for production servers, basically we do that. We do not do this for uh, we do not do this for the development servers, because if we are using Elastic IP, so there is an additional charge of using Elastic IPs. So we'll go here to Elastic IPs, and here we'll click on under network and security. Under security group, you'll find Elastic IPs. Here we'll click on allocate Elastic IP. Okay, so Elastic IP has been generated for the account. Now what we'll do is we'll associate this Elastic IP with our EC2 instance. And once we assign Elastic IP to our EC2 instance, even if we stop it, terminate it, the IP address is not lost. The IP address will be, even if we terminate the instance, the IP address will stay with the EC2 instance. Okay. Also, let's say if you change the, let's say if you want to use this Elastic IP with some other instance, okay, that also you can do. Okay, but in that case, I mean, Elastic IP can, at a time, it can only be assigned to one EC2 instance. It cannot be assigned to multiple EC2 instances. It can only be assigned to one EC2 instance. So even after you terminate an instance, you can use the same Elastic IP with some other EC2 instance. Okay. Now there are some limitations. There are some limitations in Elastic IP, which is in an AWS account, we can create up to 5 Elastic IPs. Not in an AWS account, we can say in an AWS account, in an AWS region. Or we can, yeah, in an AWS region, we can create up to 5 Elastic IPs. So let's say if you have created 5 Elastic IPs in Virginia, then you'll not be able to create more IP addresses. And this limit is region specific. So in Virginia, the limit is, actually for all regions, by default, the limit is 5 IPs. Let's say if you want to create more than 5 IP addresses, so in that case, basically we have to request AWS support. Okay, as we discussed about the limits. Okay, so limits are of two types. One is hard limit and soft limit. Okay, limits are of two types. One is hard limit and one is soft limit. Let's say for EC2, Amazon Elastic Compute Cloud. And here we'll search for Elastic IP. Yeah, here you can see EC2 VPC Elastic IPs. Classic, we will not talk about that. That is basically the older version of network which AWS used to have before, almost 5 years before. And it will not even be asked in the certification exam. Yeah, so EC2 VPC Elastic IP. So we have 5. Okay, now at the end you will find adjustable. If adjustable is set to yes, then we can request a quota increase. We can set, let's say we need 10 more IPs. So we can request AWS to increase the quota. Only if it is adjustable is set to yes. Okay, this, which means this is a soft limit. If adjustable is set to say yes, it means it is a soft limit. And let's say for some resources, let's say adjustable is set to no. Let's say for this resource, attachment per VPC is set to 5 and the adjustable is set to no. So it means it is a hard limit. Okay, hard limited means it cannot be increased. Okay, soft limit, we can request AWS and we can increase the limit. Okay, so in an AWS region, we can create up to 5 Elastic IPs. Okay, let's say in Virginia, we have created 5 Elastic IP. Okay, and let's say for some other region, we can also, in that, But some other region also we can create. Let's say if we have created 5 elastic IPs in Virginia, it doesn't mean we cannot create more IP address in some other regions. Okay, the limit is region specific. For a region, it is 5 elastic IP. Okay, do you have any questions still here about elastic IP?
No.
Okay. Okay, can we have a 10-minute break and then we'll continue?
Sure.
Okay, and also actually, 1 second. All right, so far, do you have any questions in security group or elastic IP?
Um, well, I think that's good.
Okay. Okay, now let us talk about the uh, okay, now let us talk about the details of the instance. So the very first detail of the instance you see here is the instance ID. Okay, every instance we launch in AWS basically has a unique instance ID. We can also call it as a resource ID. Okay, we also have the ARN, but this is actually we have two things actually. One is resource ID, one is ARN. ARN we already discussed, which is Amazon resource name. So for an EC2 instance also we have a ARN, because EC2 instance is basically a resource, right? And we have the public IP of the instance, the private IP of the instance. This is the IP address which is on the NIC card of the EC2 instance. So when we launch an EC2 instance, there are a couple of resources created. There are a couple of resources created, which are security group. We need to create a key pair. Volume is created.
Was there a different key pair for every instance, or can you reuse your key pair?
We can reuse the key pair. We can also reuse the security group. Two things we can reuse: key pair and security group. Volume is created. Okay, dedicated volume is created for the instance, and a unique card, elastic network interface, is created for the instance. Out of which physical resource, there are two physical resource which are volume and the unique card. Okay, these are physically created. Okay, physically created at the data center, which is basically our availability zone. So when we create these resources are created. I mean, when we create the instance, so all the resources related to the instance. Okay, resources, which means volume ID, volume and unique. They are created in the same availability zone. They are created in the same availability zone where the instance is launched in. Okay, this is very important. When we create the instance, all the resources, let's say we are launching the instances US East 1A. So all the resources of this instance, okay, resources, I mean volume and unique, these are physical resources, whereas key paired and security groups are virtual. Okay, volume and unique are created in the same availability zone. Okay, let's say you have created an instance in this availability zone, these resources will be created in the same availability zone. Okay, if we go to the console, so this is our instance. If we go to storage, So this is the volume which is attached to the server, which is basically the root disk. Let's say if we click on this root disk, okay, root disk is basically of 8 gigabytes. Okay, and if you see the availability of zone of the disk, it is US East 1D, and our instance is also running in the same availability zone, right? Our instance is also running in the same availability zone. Yeah, yeah. Our instance is also running in the same availability zone. And in networking, if we see the NIC card, eNIC, there you can see the network interface. So this eNIC card is also created in the same availability zone where our instance is running. Okay, it is created in the same availability zone. Now let's say we want to add more storage to the server. If we want to attach more storage to the server, more volumes to the server. Right now, one volume is attached of 8 GB, which is storing the, which has the operating system, right? Now let's say we want to create one more disk for our server for storing data. So we can click here, create volume, and volume type, we'll talk about this when we'll be dedicatedly talking about volume. Then the volume size, let's say we want to create a volume of 10 GB. Then we have to choose the availability zone because this is a physical resource. And this physical resource is created in a data center in the availability zone. So here basically we have to choose the availability zone. Now let's say I'm creating a volume of 10 GB and I want to attach to that server, the one which we are running. And that server is running in US East 1D. Okay, and let's say if I create this volume in US East 1A, by mistake, let's say I create this volume in this availability zone. So what will happen? We will not be able to attach this volume to that instance. Okay, we will not be able to attach the volume to the instance. So any resource which we are creating for the instance must belong to the same availability zone. Okay, any volume if we are creating for the instance or any network interface card if we are creating for the instance must belong to the same availability zone. Okay, so let's say we are creating a volume. So the volume must be created in the same availability zone, or else we'll not be able to attach the volume to the instance. Okay, let's say this volume is created, then we can attach this volume to the instance. So if you see here, it is searching for instance in this availability zone because the volume is created in that availability zone. So if we have an instance in that availability zone, then only we'll be able to attach it. If we do not have an instance in that availability zone, then we'll not be able to attach the volume to the instance. Okay, I think we made some changes in the security group. This. Okay, yeah, the IP address is same. You're not using, yeah. So okay, also there could be one question which can be asked in the certification exam, which is, let's say if we have created an elastic IP, and if we are not using that elastic IP, okay, if we are not using that elastic IP, it means if that elastic IP is not assigned to an EC2 instance, then we are charged for that elastic IP. If the elastic IP is not in use, then we are charged for the elastic IP. But let's say if elastic IP is assigned to an EC2 instance, then we are not charged for that elastic IP. Okay, so we are only charged when it is in use. I mean, when it is not in use. If we are using it, then we are not charged for it.
Cool.
So once we attach the volume, so we'll be able to see the volume by this command lsblk. Here we can see a volume is attached of 10 GB. Okay, so all the resources which we create, I mean, related to the instances must be created in the same availability zone, or we'll not be able to attach that resource to the instance. Okay, then we have status check. So here we have two types of status checks. One is system status check and instance status check. So system status check is where the hypervisor is running, where the bare metal server. Okay, this check is basically, it is checking whether the hardware is healthy or not. Hardware where this EC2 instance is running, right? As we discussed, that the EC2 instance is running on okay. Yeah, so hardware is this one, bare metal. Okay. I mean, our EC2 instance right now, this is our EC2 instance running. So it is running basically in this architecture only. There is one physical hardware of AWS in an availability zone where hypervisor is installed, and top of that, our EC2 instance is running. Let's say this EC2 instance. Okay. So one EC2 instance is running, and system status check. System status check basically checks whether this hardware is reachable or not. I mean, not hardware, whether this hypervisor is reachable or not. Okay, hypervisor is reachable or not, which means it is healthy or not, it is running or not. The second thing is instance status check. It will check whether the instance which is running on the hardware is running or not, is reachable or not. Sorry, it is reachable or not. Okay, it is accessible by the hardware or not, that it will check. If it is not, then it will mark it as unhealthy or failure in the system check. And if there is a failure, then AWS will ask us to reboot the instance. Okay, then AWS will be asking us to reboot the instance. Okay, one is system status check, which is at the bare metal level, at the hardware level, at the data center. And this instance check is whether it is basically checking whether the instance is running on that hypervisor is reachable or not at the hardware level. If any of these checks fails, basically we'll not be able to log into the instance. I mean, the server will not be reachable if any of these status check fails. So basically what we do is, if any of these status check fails, we reboot the server. And when we reboot the server, it is basically sent to some other hypervisor. It will be changed to some other server. Now let us talk about monitoring. So by default, AWS provides basic monitoring for EC2. Okay, by default, AWS provides basic monitoring for EC2. Basic monitoring, it means we'll be able to see, yeah, actually in basic monitoring, we'll be able to see the CPU utilization, status check, network utilization. We'll be able to see the disk utilization. Okay, we'll be able to see lot of resources, lot of resources, resource utilization of our EC2 instance. Okay, now this is basic monitoring. Okay, by default in our EC2 instance, when we launch our EC2 instance, okay, AWS offers basic monitoring, which is free of cost. We are not charged for the basic monitoring. Okay, we are not charged for basic monitoring. And in basic monitoring, there is a delay of 5 minutes. There is a delay of 5 minutes. Where is the delay? The delay of this graph. Right now, it is not showing the accurate data, current data. It is basically showing the data of 5-minute delay. Okay, let's say if you want to see for 15 minutes, last 15 minutes. So it is basically almost having 10 minutes delay. Okay, if you see the server time in UTC, it is 8:36, and here it is, sorry, 18:36, and here it is 18:25 UTC. So yeah, right now we can see basically a delay of almost 10 minutes, but officially basically AWS claims that there is a delay of 5 minutes. Okay, in basic monitoring, there is a delay of 5 minutes. And AWS also offers detailed monitoring. In detailed monitoring, the interval is of 1 minute. Okay, and this is the default one. And no additional charges for this. For basic monitoring, there is no additional charges, but there is a delay of 5 minutes. With detailed monitoring, we'll get the data after every 1 minute, but there are additional charges for this. Okay, for detailed monitoring, there are additional charges. And it is basically just a setting. So here you can see in monitoring, manage detailed monitoring and enable detailed monitoring. And here you can see after you enable detailed monitoring, the Amazon EC2 console displays monitoring graphs within a minute period of for the instance, and additional charges apply. So basically there are some additional charges for detailed monitoring. Okay, do you have any questions still here?
For the monitoring, isn't there also a way to see like how much storage you have left and how much memory you're
Yeah,
utilizing?
two things it doesn't show. One is disk utilization and memory utilization. That also actually we can configure using CloudWatch.
Okay.
Not using CloudWatch, actually in cloud, I mean, we need to install the CloudWatch agent for that in the instance. We need to install the agent and we need to configure the agent, and then basically it sends the data to, it start displaying the data of disk utilization and memory utilization.
Okay. Do you know if that, how much that costs, or
It's
expense?
actually for that also there is no additional cost. Just we need to configure it.
Oh, okay.
Okay, now let us talk about snapshots. Okay, so when we create an EC2 instance, so let's say right now our EC2 instance is in running state. Now we need to take a backup of our EC2 instance. Do you know what is snapshot?
No.
Okay, now let's say if we want to take a backup of our EC2 instance. Okay, let's say our EC2 instance is basically running a dynamic application which keeps on updating the data. Daily, some data is basically added inside the EC2 instance. Okay, through the application. Let's say daily customers are logging in and creating accounts. Let's say it is a let's say our EC2 instance is hosting a website where user sign-ups, and daily let's say hundreds of users are signing up, and our EC2 instance is basically storing the data, right? So in that case, daily new data is being basically added to our EC2 instance. Now what we want to do is we want to take a backup of our EC2 instance. Okay, so that let's say if something goes wrong, we can restore the data. Okay, we can restore the data, or we can get the application back up and running if something goes wrong, right? So in that case, basically we can use snapshot. What is the snapshot? Snapshot is just a replica of our EC2 instance. Not our EC2 instance, the volume of our EC2 instance. It is a replica of the volume of our EC2 instance.
Is it of like if you attach an additional volume, so you have your root and then you have your data volume, would it be of both?
No, it's not a volume. It's basically a replica of the volume.
Well, if you had more than one volume attached, like you
No,
have.
no. Let's say we have this instance running, and this instance, let's say, has one volume attached. For example, one volume attached. Now we want to take a backup of this volume, because in volume we have the data stored. Okay, volume is just a disk where the data is stored, right? Right? Do you agree?
Yes. So the snapshot or the replica is taken of the volume, not of the instance. Is that correct?
Yeah, actually, yes. The snapshot is basically created of the volume, and volume is basically storing all the data. The operating system, everything is basically, and the data is basically stored inside the volume. So when we create a snapshot, so of that point of that point of time, what we do is, we basically capture the volume. We capture the volume in the form of a snapshot. Okay, we can say it is just a replica. Let's say right now I'm creating, let's say if we create a snapshot now, so of this point of time, it will create a backup. Okay, of this point of time, it will create a backup, which means once the snapshot is created, the data which was inside the volume till this time will be stored in that snapshot, and the newly created data will not be replicated to that snapshot. Okay, only the data of this point in time will be stored inside that snapshot. And let's say after some time, if something goes wrong, we can restore it back to that snapshot. Are you getting?
Yes, but I'm still confused as to the scenario where there's more than one volume attached to an instance.
Uh-huh.
So
So in that case, we can create a snapshot of multiple volumes.
okay,
Each of the volumes volume will be having its individual snapshot.
okay, gotcha.
Yeah.
So if you wanted to clone an instance, you could, in theory, take a snapshot of the root volume, and if it had a data volume as well, you could take a snapshot of that, and then you could create a new instance utilizing both of those snapshots.
Yeah, exactly.
Great. Cool.
Yeah, so the snapshot has been created. And AWS recently, okay, let's delete this one. I'll show you one scenario. Okay, right now we are logged into the EC2 instance. And in the EC2 instance, I'll create one directory, let's say data. And in this directory, data directory, I'll create some files. Let's say 100 files I'm creating here. Okay, I've created 100 files here. Now I have a lot of data inside my server. Let's say each of these files are created by some customers. Now I want to create a backup of this data, which is stored up in my instance. So what we'll do, we'll go to the instances, we'll go to storage, then we'll click on the volume, and we'll create a snapshot of that volume. Okay, and if we go to snapshots, now let's say by mistake, once the snapshot will be created, by mistake someone ran, by mistake if someone deletes that data folder, with rm command we can delete the data. So let's say if someone deletes the data by rm command, so the data will be lost, right?
Yeah.
So we create the snapshot of a working state. Let's say everything is working fine, everything is working smooth. At that point of time, we create a snapshot. So right now, everything is looking good inside our EC2 instance. The data is there, everything is working fine. So at that point, we have created the backup. We have created the snapshot and it is completed now. Now, let's say by mistake, if someone ran rm-rf data and all data is gone, right? All data is gone, application is down, and yeah, the customer data is gone, let's say. Now in that case, to get back to the working state, okay, working state we have captured in the snapshot. To restore the backup, okay, basically right now we are talking about restoring the backup. So to restore the backup, AWS has recently introduced that feature. Actually, they have introduced almost 2 or 3 months back. That is, we can replace the root volume. Okay, here we can just right click on it and monitor and troubleshoot, replace root volume. And we can replace the root volume by a snapshot. Then create replacement task. This is actually added almost 2 months back. Okay, it has started the volume replacement. I mean, it has started the a restoration of the backup. Yeah, and we are logged into the instance. I mean, the backup is now restored. And here you can see the data directory is there. The data directory is there and all the files which we created are there. So with snapshots, we can create the backup of our data and we can easily restore it. Okay, so that we do not lose any data. Sorry.
So prior to 3 months ago, would you just have to start over? Like you'd have to delete the instance and start a new instance with that volume?
Start a new instance with that volume.
You said that the replacing the root volume was a new feature that was just developed a few months
Yeah,
ago.
yeah. Before, what we used to do is we used to stop the instance.
Okay.
We used to stop the instance, and then what we used to do is we of this snapshot we used to create a volume. Of this snapshot we used to create a volume, and then after stopping the instance we used to detach the old volume, the corrupted volume. We used to detach it, and we used to attach the new volume which is created by that snapshot to the instance, and then we used to start up the instance. So that was actually a manual way to do it, and it used to take 5-10 minutes, and there used to be a downtime also. This was very fast. Within 1 minute it was done.
And you don't
There
have
was
to
a downtime. No, there was a downtime, but it was of 1-2 minutes. But if we would be doing it manually, it would take 5-10 minutes for stopping the instance, then detaching the volume, going to snapshots, creating the volume, then attaching the new volume to the instance, then starting the instance. So 5-10 minutes it basically takes. Whereas this feature basically is automated. It takes 1-2 minutes, and we don't have to manually do anything. Manually do anything means creating the volume and stopping the instance, and anything we don't have to do.
Is the instance stopped with the new feature, or is it able to
No,
do?
no, no. It was not stopped. It was in running state. Actually, it went to reboot.
Okay.
Yeah, it was rebooted.
Oh, okay.
Okay, snapshot is a very common practice, which is basically used in industries for taking backups of the servers. Now let's say okay, now let's say we want to increase the storage of the instance. Let's say we have one volume attached on our EC2 instance, which is of 8 GB. Now we need to scale up the storage. Now let's say our EC2 instance is using a lot of storage, it's basically storing a lot of data, but consuming a lot of storage. So in that case, what we can do is we can increase the volume. From here, we can increase it to, let's say, 100 GB. Okay. Now there is a limit of a volume. There is a limit that we can create a volume of up to, not volume of, volume up to 16 terabytes. Okay. We can create a volume of or up to 16 terabytes. We cannot create a volume more than 16 terabytes. Okay, that is the maximum size of a volume which we can create. Yeah, here you can see minimum 1. Okay, 1 GB, that is actually depending on the volume type, but the maximum size is 16 terabytes. Okay, the maximum size is 16 terabytes. Okay, this can also be asked in the certification exam. The maximum size of volume which we can create. for a EC2 instance. So it is 16 terabytes. Now let's say we have increased the storage of our instance to 100 GB. Okay. So now let's say my server is not utilizing that much storage. I want to scale it down back to 50 GB. So in that case, let's say I'll click on modify volume and let's say we'll set it to 50 GB. So it says the volume can only be increased, but it cannot be decreased. Okay, so we can only scale up the volume. We cannot scale down. Okay, we can only scale up. We cannot scale down. This can also be asked in the certification exam. We can only scale up the storage. We cannot scale down. Okay, mostly in the certification exam, you will be seeing scenario-based questions. Okay, let's say Dave is a user or a company is trying to set up, wants to scale up their storage, and they want to, after 2 months, they want to scale down their storage. So I mean, they will be giving you some 4 options, which will be saying storage cannot be scaled down, or storage can be easily scaled down, or AWS doesn't support scaling down, or AWS doesn't support scaling up the storage, or none of these, or all of, yeah, none of these. So the answer would be we can only scale up the storage, we cannot scale down. Once we have increased the storage, we can not decrease it, we can only increase it. Okay, do you have any questions still here?
So what would be the workaround for scaling down? Would you just have to create a new volume with less storage? And
yeah, in that case, what we can do is we can create one volume of less storage, let's say 50 GB, or the size which we want to scale down to, and then we can copy the data from one volume to another volume, and then we can attach that volume to the instance and delete that old volume.
Okay.
Yeah, but that is a lengthy process. There is no official way to do that.
Okay.
That is more system admin thing.
Oh, for the snapshots, are snapshots already taken on like a regular basis without you having to do anything? Is it like once a day it'll run?
There is, yeah, by default AWS, there is no, but I mean, by default AWS doesn't create any snapshot. Let's say we want to automate it, we can automate it using lifecycle manager. In this, basically, we need to create a lifecycle policy, and with this policy, we can create automated snapshots. We can create, let's say we want to create a snapshot daily. Okay, so actually this is also added last year only. Before that, they didn't used to have this feature also. So with this, basically we can create a snapshot. We can automate the snapshot creation. Let's say we want to create a snapshot daily. So in this, basically we can create a policy saying that it will be, create snapshot daily on a specific interval of time. Let's say daily at 12 p.m. In the night, create a snapshot, and we can also set a retention. Let's say we are creating the daily backups, and let's say after 90 days, if we check the backups, so it will be 90 backups. Okay, but we don't need 90 backups. You only need, usually company keeps backup of last 30 days. So that also we can do using this lifecycle policy.
Okay.
This will not be asked in the certification exam. So here, basically, we just need to choose the policy type. It depends upon what resource we want to create for. Then the resource type, let's say we want to create for, let's say for instance. So here we have to give the name of the instance. So this is the description. let's say my policy. Then we need to give the name of the instance.
And these can be taken without stopping the server. The server just keeps running, right?
Yeah, it will always keep, yeah, without stopping the server. And here basically we set the retention, like how many backups you want to keep, when to create the backup, whether to create daily, weekly, monthly, yearly, all those things basically we can do. Okay, do we have any questions still here in EC2?
No.
Okay. Okay, I think let us keep it till here. And yeah, let us keep it till here and we'll continue in the next session.
Okay, that sounds great. Thank you.
Okay. Okay, so what I'll do is I'll provide you the one second. Okay, what I'll do is I'll provide you the I'll forward the AWS book and the practice test books which are officially by AWS to Matt, and Matt will forward you.
Okay, sounds great.
Okay. Okay. All right. So we'll be meeting again, I think, next weekend, right?
Yes.
Yeah. Okay. All right. Thanks. Have a great weekend.
Thank you. You too. Bye.